Hello, 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 hello. Hello, 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 hello. Hello, 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 hello. Hello, hello. హలో 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 సౌండ్ బాగానే ఉంది కదా. హలో 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 బ్రో, అదేం పెంచక్కర్లా, బాగానే ఉంది, సరిపోతుంది. ఇది ఫుల్ మ్యాక్సిమంలో ఉంది ఇది. హలో, గుడ్ మార్నింగ్, మైక్ టెస్టింగ్ 1 2 3. వెళ్ళదు, మైక్ ఆఫ్ చేసి ఉంది, అదిగొచ్చు డిస్ప్లే మీద మైక్ ఆఫ్ చేశాను. యూట్యూబ్లో మాత్రమే వెళ్తుంది.
Hello. Hello. Is it fine? Hello. Hello. Right. Okay. Okay. So, what do you think? In aggregate, what we are doing? Sorry. What we are doing in aggregate? Hello. Okay. Yeah. What we are doing in aggregate? At zonal level, we are doing assessment, and at disaggregate, what we are doing? Household level or individual level, right? So normally, aggregate meaning what we are doing indirectly. Whenever we are summarizing the information of a group of observations or a special unit, we tend to develop an aggregate level model. Okay? So for zonal level, what we are doing indirectly, we are assuming that there are households or population in that zone, right? Using that, we are predicting number of trips. So this type of model development is known as aggregate level development or model development using this data. At disaggregate, what we are doing is we are asking information related to how do they travel or what is their mode of choice of travel. So what we are doing indirectly, we are assessing individual information or observation, and we are developing our model, right? So if you see, mode choice models will fall into which category, aggregate or disaggregate? Mode choice models will fall into which category of modeling? Hmm? Disaggregate. Why? Because whenever you're collecting data, you're asking people how they are traveling or which mode of transportation they have chosen, right? You're not using an inference related to how a particular spatial unit is choosing their mode, right? You're using this inference that how an individual is choosing a mode, right? Whereas when you predict number of trips, or when you predict these many trips will be going from this area to that area, so you are aggregating that information that 1,000 people from this area will be traveling, and out of those 1,000, 500 will be going to this specific spatial unit, right? So this step of data collection and modeling is known as aggregate level information. So in generally you are summarizing your information somehow over a spatial unit, okay? So this is what has been written over here. So aggregate model demand that summarizes the data at an aggregate level, and at disaggregate you tend to do, or you tend to collect data at individual level and model it to develop your models, okay? And mode choice models will come under disaggregate level. Then there is top down bottom approach versus bottom up models. So what do you think? What is top down approach? So yes, but the general idea is in the top down model approach, what you are doing indirectly, first you are predicting, or first you are using the information at a bigger spatial unit. Let's say if I want to get the GDP of a city like Vijayawada, right? So I can have two different approaches. Either I collect data related to Vijayawada, predict what will be the GDP of Vijayawada, or in future, let's say if I want to do this for 2040, what I will be doing is I will be identifying that what will be the projected GDP of India in 2040. From that projected GDP of India, I will be predicting what will be the projected GDP of Andhra Pradesh. From Andhra Pradesh, I'm going to predict what will be the GDP of Vijayawada, right? So this is from the top I have started, meaning at India level estimates were available to me in 2040, because IMF tends to predict, or government of India also tends to predict what will be the overall GDP in 2040, 2050, so on and so forth, right? So using that, I'm using information from the top and coming down at the bottom, or at a micro level, right? So that is known as top down bottom approach, okay? Whereas in the other case, I will be predicting the GDP of India using or collecting data from Vijayawada, right? If Vijayawada's GDP in 2040 will be this much, so it is going to contribute, let's say 10% of the GDP to Andhra Pradesh. So the overall GDP of Andhra Pradesh will be this much, and Andhra Pradesh is contributing, let us assume 10% again to the India's GDP. So overall GDP of India will be this much. So from the bottom I have started, and I have predicted that the GDP of India will be this much for 2040. So there are two different approaches, okay? Now, once we have a basic understanding, hello, hello, hmm? I will put it, no, it is fine. Yeah. So we got an understanding where different type of model will be used in different stages, or related to different transportation demand models. Now let's see a basic application. Let us assume that you have already developed the models. Now how you are going to use those models that you have already developed? So this is an example where we are showing, okay, on the screen it is not visible. This is an example where we are showing, this is the existing map of MMR region, okay, and what is the existing infrastructure that is available in Mumbai. So for example, they have airport, they have planned for two airport, right? One in Navi Mumbai, one is the existing airport, right? These are the networks, right? Major roads or major highways. These are minor roads or minor highways available inside the study area. There are metro lines, so on and so forth, okay? Now, once I have developed a model, what I can do, I can assess what will be the future demand. And using this, I will get an understanding that which are the major points that have to be connected, or this is the proposed plan of highway for 2041. This is the proposed plan of highway sorry, this is for suburban or public transportation system, and this is for highways, which are the places that have to be connected. So for example, if we see generally, the outskirts of the study area was not having any existing network, road network, which tends to provide direct connectivity. But we know in future, the way Mumbai will be growing, the way demand will be going for transportation, we have to connect this outskirts places, because these places will be developed based on the proposed master plan given by the government of Maharashtra. Okay, so using all those information, we can propose which are the new highways that will be coming into picture, which are the new public transportation routes that will be coming into picture. Okay, so this is the general application of your 4-stage travel demand model, and this type of maps you are going to see in a lot of reports, CTS report, or mobility related report for different type of cities. Okay, now whenever we are assessing, let's say you have developed the model, all the 4 stages you have developed, so what will be your measure of assessment? How you are going to assess that particular, or let's say you have proposed that let us have this highway which will be catering to the demand of the future population. So how you are going to assess? So there is two possibility, right? Let's say if I talk about Mumbai also, it is something like this, right? So there are two possibilities. I know we have to provide a connection between these two places. There is one small future hub, commercial hub, that is coming over here, and there is one more future commercial hub that is coming over here. Now there is two possibility that I can propose on road network in a way which will connect this and reach the major destination, or I can have this, right? So there are two possible routes that I have proposed. Now which route will be more feasible or more better? So how you are going to do that assessment? So there are certain quantifiable ways in which you can measure the impact of different route, and the government is telling that we can only have one route, we cannot have both the routes. So somehow you have to decide which route will be more feasible or more important for you to build, right? So how you are going to assess that impact, or how you are going to assess what are the benefit that you are going to provide to the system if you build this route, or what are the benefit that you are going to provide to the system if you build this route, right? So you need to have certain measures which you can quantify it in an easy way, right? So those are, firstly, measure of congestion. Let's say if this route is built, how it is going to reduce the congestion between these two major destinations, right? And when I talk about congestion, you are going to also understand or assess the impact of delay. If this direct route is provided to the users, let's say previously they were being connected by this route, but they have to travel like this. This is the existing route, and this is the new route that you have proposed, right? So we clearly know that it has higher travel time compared to the proposed route, right? But which one will be better, whether this or this? You are going to assess how you are going to reduce the impact of congestion on the routes, right? How the travel time savings will be enhanced. So one is a measure of congestion. So what we are going to do, measure of congestion. Here you can use LOS based method. We all know how to assess LOS, particularly at link level, using V by C ratio, right? You will identify that current LOS of this infrastructure is, let's say, F. Once this route is proposed, the LOS will reduce from F to, let's say, C. But if this route is proposed, the LOS will reduce from F to E. So which is a better alternative, this or this? This. Because the way in which we have quantified LOS, or the impact reduction in LOS can be measured, V by C ratio, this has higher impact. Okay. Then travel delay, again you can conduct speed volume delay surveys. You can assess what is the average speed currently you are seeing on the existing highway. Then you can assess, once this is suggested or this is developed on the modeling framework itself, right? So what we are doing, first we are developing for the base level, then we are introducing new set of highway, and then we are rerunning our model, right? And then what is the new level or new travel time measures that you are going to get, or the delays that you are going to get, that you can assess and you can evaluate which sort of outcome will be better in your model. Okay, so travel delay, how to quantify travel delay? It is based on person hour. Okay, person hour in the sense, let's say previously this highway, okay, used to have a delay of 20 minutes per person, okay, or on an average the delay was 20 minutes, right? So how many people are using it? Let's say 10,000 people were using it, so overall delay will be 10,000 into 20, okay, and based on this you can assess what is the overall delay reduction intervention on this existing highway, right? So let's say you have increased the width of the highway, meaning you have increased the capacity. To measure a pollution, how you are going to assess it? Let's say previously the delay was this much. Because of the delay we know that the delay is directly associated with the pollution emissions, right? Now the delay or the volume has decreased by this much extent. You can quantify by proposing these measures how the overall pollution or the emissions will be reduced. Okay, economic welfare, how you are going to assess based on the economic welfare is by assessing based on travel time savings or equity, right? So what is equity? The degree of fairness that you can provide in the society. That is how you tend to define equity, right? Meaning the fairness by which you can distribute the benefit in the system, right? How we can assess that? We can assess it based on the generalized cost or the overall cost of travel. Now because of the new proposed measure, how your travel time has reduced. If your travel time has reduced, then what has happened? The cost of travel has also reduced, right? And it has become more affordable for other segment of population, right? Net benefit to travelers by income class, meaning for different class of people, how what are the affordable options that you have provided, and how they are traveling, or what amount of income they are spending in order to travel from one point to another point. Okay, now let us understand, we have talked about in general about how you are going to assess the plan, or one measure is better than the other measure or not, how to assess it. We have quantified based on certain measures. We can quantify very easily whether this plan is more suitable compared to the other plans or not. Now for all this exercise that we are going to do, what are the data requirements? Okay, so firstly, whatever data we are going to collect, we will be collecting it, let's say, over a period of time. So this type of developing models for this type of transportation system, the data requirement is somewhere around 3 months to 4 months. You will be keep collecting your data. Once you have collected your data, simultaneously you will be trying to understand your data, meaning by cleaning your data, whether this type of data makes sense or not for your modeling purpose or not, right? There might be some missing values. For example, if you collect survey also, and if you ask some people that they have to report their income, right? In many of the cases you may end up getting no response from the people. So that's an empty value or a missing value, right? So how you are going to assume certain number for this missing value if income is very important indicator for you while developing your model, right? Or whether if income is not that important, then how you are going to discard this, okay, based on what logic you are going to discard it, right? So data gathering and cleaning is a simultaneous process that you keep doing with the data collection process. And To understand this whole or the development of the 4-stage travel demand model, the data collection, accuracy of data collection is very important. Now, when I say accuracy, how you're going to measure whether the data that you're collecting is accurate in nature or not? Hmm? What are some of the key exercises that you do on the data to comment whether this type of data is accurate or not? Let's say if I've given you some exercise of data collection, right? And one segment of the class is telling that based on my data, this should be the model, and based on other, segment of the class, this should be the model. So firstly, I have to identify which section of the class has collected the data correctly, right? Which is the more accurate way of data collection that they have followed, right? And then using their model, I will be having more confidence, or whatever outcome they are showing me. Once the data is accurate, then only I will have confidence on the outcome, right? So how to identify that this type of data or this data collection exercise was more accurate compared to this? How to identify it? Hmm? What are the exercises that you can perform to understand your data accuracy? So have you heard about sample and population in statistics for data collection? Have you heard about sample and population? How many of you are hearing this for the first time? Sample and population. How many of you have taken statistics in general, or seen some course related to statistics online, offline? No one has taken any stats related courses? Not even online? Hmm? So normally when I say data collection, whenever I'm doing, developing models, right? Let's say I want to develop a travel demand model. I want to understand how people, let's say, to be very specific, I want to, the surveys, you may end up giving a lot of responses to different surveys, right? For example, whether this phone is better than that phone or not, right? Or what is the product people are preferring in current age scenario, which phone is more trendy, which type of product is more trendy for the population, so on and so forth. You may end up giving a lot of responses to different surveys. So in that, what they are doing, they are collecting responses from you, and they are trying to analyze the market trend, that which is an important factor for this segment of the population, for youngsters, for middle income group people, so on and so forth. They tend to develop different models. So are they collecting data from all the youngsters? No, right? To develop or to predict something, are they collecting data from every young population in India? No, they are collecting data just from a part of the population. That part of the population is known as sample, right? So we have this understanding that the overall population of India is somewhere around 140 crore, right? And if we want to develop any model or predict anything or the trends in general, we don't have to collect data from all the 140 crore people and try to understand. What we can do is I can collect data from, let's say, 5,000 people, and I can analyze the trend or what is the requirement of the population, right? Now, what I'm doing in generally, using the observation of this 5,000 people, I'm generalizing it for the whole population, right? So my first requirement will be whether my sample, this is my sample, whether my sample is a good representation of population or not. And what do I mean by a good representation of population? Because in general, what I'm doing, using this 5,000 information or data points, I am doing prediction for the complete population, right? So for that, I have to firstly say, because I'm generalizing it for the whole population, I have to firstly say this 5,000 people are representing my population. right? If that is not true, then whatever models I'm going to develop will not be accurate, right? So the first requirement to assess your data is to check the representation of the population, whether your sample data is a good representation of the population or not. And how we are going to do, or how we are going to compare it, what are the things that you can do to assess whether your sample is a good representation of population or not. Hmm? What are the exercises that you can perform? Hmm? And it's a very important exercise, particularly whenever if you end up doing a statistical job, or you end up doing any type of survey for any sort of firm. You have to, first thing that you have to prove to the client is whether the observation or the data that you have collected is a good representation of population or not, right? Otherwise the client or that firm will not agree to whatever you are saying, right? Because as such you have not proved them, or you have not ensured them that the data tends to represent the complete population or not. So it's a very important exercise in research, and all the consultancy work, in any sort of work that you're going to do, trying to understand the trend or any sort of thing, right? So what do you think? How we can quantify this? A good represent terminology why it looks good, right? Good representation of population. But what do I mean in a quantifiable way? What do I do to understand whether it tends to represent the population or not? What sort of exercise I have to do? Hmm? So what you can do is you can compare certain statistical output of your sample with the population. Statistical output in the sense, let's say if I have an household size, let's say during the survey I'm asking you how many family members are there, you know, and what is your income level? You can give me a rough bracket. How many vehicles you are having? You can again give me a rough bracket, right? What I can do, I can use this information, household size information, HH size info, and I can compare it with the Census of India report, right? Because Census of India every 10 years they do exercise, and they identify how many people are there in India, or different district, different states. They identify how many members are there in every household, right? I can compare that with my data, and if I'm getting same mean, let's say using this 5,000 sample, the average household size, I got this to be somewhere around 4.8, and Census of India is telling me that the average household size in Vijayawada district, let's say you have conducted this exercise for Vijayawada, is 4.9, right? Then I can say the exercise or my data, my sample is a good representation of population. Okay, same thing is true for income. Let's say you have this idea what is the average income or GDP per capita in Vijayawada, right? If you have that information, let's say on an average it is 25k, and from your survey you got the answer to be 23k. So you got this understanding that whatever population or the data related to the population I'm collecting, that is actually representing my population. That means whatever data I've collected is correct. Let's say if your survey tells that the average income of a household is 50k, but that the Census of India report is telling you that it is 25k. So there is a lot of difference between what you are reporting and what is actually true on field, right? So here what is the problem? If you tend to develop model for using this data, you cannot generalize it for the whole population of Vijayawada, right? What you are doing here? You are developing a model for high income group people, because your data is telling that the people who have responded to your survey are mostly high income group people. right? So if you want to develop a policy about affordability, public transportation, they might not be true in your case, or using that data, you're not giving a good answer, right? So that is why it is important that you end up doing proper exercise of comparing your sample and population. Okay. And normally in this, how we tend to measure the accuracy is we compare the household survey that we collect for transportation, we compare it with the census report. Okay. Secondly, other than that, what we additionally do is we conduct certain traffic studies. Okay. Because in general, what is the output that your four-stage travel demand model develops? What is the output? Towards the end, it is traffic volume, right? That it will tell you that in an hour, 10,000 vehicle will be observed in this part of the stretch of the road. This is the final output. Now what you can do, this is from the model. You can also go on field, collect some data, and within 1 hour, how many vehicle has crossed this particular segment of the road. Let's say if you end up getting 12,000, which is field data, right? And this is model data, then you can have a comparison that, okay, whatever I'm saying 10,000 is close enough with 12,000. That means my model is more or less accurate, right? Now for this exercise, there are certain things, or there are certain ways in which you end up doing. How to identify, firstly, how to identify which are the links that I'm going to compare, right? Because when I say model, model is not going to give you altogether a very accurate result for each and every link, right? Because overall it is giving you traffic flow on each and every link. But if I compare it with each and every link, is it going to give you accurate result? No. At an aggregate level, model tends to give you an accurate result or an accurate output. Okay. So which are the points which I have to identify, on which I have to perform this exercise? Okay. And those type of surveys are known as cordon survey or screen line surveys. Okay. Cordon survey, let me give you an example. So what we have done in general, in the four-stage travel demand model, we have identified that this is my study area, which is divided into different zones. From this part, how many trips are going to other parts? This is what we have identified. This is the route, right? So these many trips will be loaded on this route using a specific mode of transportation, and this is true for all the zones or for all the study area, right? Now what I will be doing, I will be identifying some specific points. Like for example, if I say, if I compare my model output with field observed output of this road, okay, so I am saying that 10,000 people, let's say there were 1 lakh trips starting from this area, and 10k people, 10,000 people were going to this area. So that means all the 10,000 trips will be loaded to this route, because there is only one route possible, let us assume like this. And if you see or collect data on this route, you may end up getting that it is not 10,000, it is just 5k. There is a lot of difference, what you have predicted and what you are observing, right? Then you identify, no, there are some people who are traveling in a way, like for example, first they are dropping someone in some other zone, for example, they are family members, they are children, and then they are coming to this area, right? So okay, so this 10,000 people who were supposed to go to this zone are actually going by some other route, or they are derouting themselves, right? So this is a possibility with each and every zone, or there can be a possibility with each and every zone. So how to identify, or how to say whether my model output is good enough to capture all this information or not? So what I am going to do, I'm going to identify some bottleneck situations in my study area. What are those bottleneck situations, or what are those specific routes where most of the people will be using it if they want to cross one part of the study area to the other part? For example, if there is only one bridge, there is a river, right? and the city is divided into two different parts, right? Now no one can deroute because there is only two bridges. One bridge is this, another bridge is that. So even though you deroute yourself, you are going to come on either of these two bridges. So what I'm going to do is I'm going to identify from this part of the study area, which is, let's say, these many zones, right? I'm going to identify from this part of the study area how many trips were supposed to go to that part of the study area. I'm not now modeling each and every zone. I'm modeling a part of the study area together. 5, 6 zones together or 10 zones together. Got it? And these 10 zones, how many trips were supposed to go on the other side of the study area, meaning 10 other zones. Okay? And there are only two bridges feasible to go from here to there. Right? Once I have this understanding, I am predicting that 50,000 people are going from this part of the study area to that part. That means 50,000 vehicles I should be counting on these two bridges, right? Once I'm getting that to be, let's say, 45 or 48,000, I have developed a good enough model. Okay, and this is known as what? Screen line survey. Meaning what you are doing? You have developed your model, but to validate your model, what you have identified? Some bottleneck situation in your study area. And this bottleneck situation is nothing but dividing your study area based on some natural boundaries and where there are only set of, fixed set of opening points, right, which connect this part of the study area to that part of the study area. So river can be that, right, where there are limited open points to connect two different part of the study area. What else can be there which we can assume as a screen line, or where we can do this exercise of performing a screen line survey? Railway line, yeah, railway crossings, right? Because we know that most of the studies, most of the study area, right, there might be some of the cities that don't have river, but most of the cities have railway line, right? And mostly if you see, railway line or the development around a railway line is more or less in between of the city, meaning this part of the city will also be developed and this part of the city will also be developed. But if it is a railway line, there are few openings, either by bridge or crossing, right? So let's say you have developed model for different part of the study area. This is how you have divided the study area into different zones, right? So now instead of validating your trips between these two zones, what you are doing, you are validating this part of the study area or exchange of trip between this part of the study area and this part of the study area. And it's an easy exercise because as I've shown you previously, right, this is a difficult exercise to validate your output, but this is a relatively easy exercise to validate your output, right? So for example, here you have identified there is some other route also feasible to go to this zone. So to how many different routes you are going to do that exercise, or you are going to collect field data to validate your output. It is very difficult, right? In this case, what happens? There are only 4 points on which you collect data and you have to validate your model. So is it clear to everyone how we are going to use model we have developed, but how we are going to use screen line survey to validate our model? Because it is very important to validate our model as well, right? Whatever model you are developing, you should be validating it with field observation, right? And this is a relatively easy exercise to perform to validate your model. Then other type of surveys or data that you are going to collect throughout this exercise also includes employment related surveys. For example, which area are going to develop employment in future, what is the current employment state, so that for the future prediction particularly it will be more reliable for you to predict the models. Now let us talk about, so we have discussed this particular part, that what will be your input, what are the 4 stages that you are going to develop, and how you are going to compare the output, right? Important indicator related to output are link flow and the speed on the different links, right? Now overall if you see how the travel demand model will look like, okay, in general. So this is what we are talking in terms of philosophy, that okay, we are going to develop this, we are going to develop this is the output, that is how we are going to validate it, this is the data requirement, so on and so forth. But in general, if you see the travel demand model, how the output will be, you are going to observe the output. So the first thing that you are going to see is this particular part, which is known as trip generation. Okay, and what this is telling you, this is telling you two information. One is production and another one is attraction. Okay, what do you mean by production? Starting, origin, from home. Okay, so that is quantified as production. Attraction, number of trips that are going to get attractive, and that is a activity, or that is a characteristics of commercial areas, right? So once we identify how many trips, so this area, we have identified how many trips are going out of this area. We identify how many trips are going to get inside this area, or going to get attractive to this area. So this first stage is known as trip generation. Okay, and the information, if you see, there are three zones. You will get information about all the three zones, how many trips they are producing, and all the three zones, how many trips they are attracting. Okay. Now, what you are going to do, once you have this, which is trip generation, now you convert it to trip distribution. How? How you are going to do this? For example, I know there is 100 trips going out of this, 50 trips are going to come to this. That means, and if there is one more zone, that means the 100 trips that have started from this area, and this is producing 0, let us assume. That means the 100 trips that have started from this area, 50 are going to go here and 50 are going to go here, right? So you have balanced it. So somehow you have converted, if let's say if I put it spatial unit information, or spatial unit 1, this is 2, this is 3. Now I've mapped indirectly actually this attraction and production, how they are distributed among themselves. Okay, so here I have converted it to a matrix. Okay, and this matrix is known as OD matrix. This matrix is known as OD matrix, meaning origin and destination. Here you are understanding that from 1, how many trips are going to 2? From 1, how many trips are going to 3? Here you have identified from 3, how many trips are going to 1? From 3, how many trips are going to 3 or 2? Once you have this, then for this OD pair, what is the mode share? Okay, so here I have identified that 15 are going to take mode 1. Let us put it like public transportation, private mode, and 25 of this trip exchange are going to be catered by public transportation. Okay, so mode 1 and mode 2, and the last stage is route. So I know for this OD pair there are 3 different routes. One is this, second one is this, third one is this. 3 different routes available. Route A, B and C. Now the exchange of trip, which is let's say 100 trips are going to go from here to here, point 1 to 2. Now this 100 trips, how I am going to distribute this 100 trips on these 3 different routes, right? So it is important so why it is important, or how we are going to do this? Can you give me some inference why it is important to redistribute them on different routes? Why it is important, let's say, to consider different routes and reroute them to different routes? If there are 3 possible routes, because this is how we travel, right? This is how we travel. If we know there are 3 different routes possible, and if you are traveling during morning peak hour, right, so you know that everyone will be taking the shortest route. This route, suddenly what will happen to this route? If this route is loaded, or all the 100 people have taken this route, and if you or let's say all these 60 people have taken this route, now those remaining 40 people, what will happen? They will see a lot of congestion on this route, so they will redistribute them. So 20 will go in this route. Again, this is the second shortest route. Now again, this route has also loaded, so remaining 20 people will be going to this route, right? So this is how you have redistributed the trip, and because this is how actually people travel, right? Once they see that this particular route is very loaded, they will try to find some alternative route, right? So you get traffic assignment. So you got an understanding what exactly a four-stage travel demand model looks like, right? Now let us get into details of developing these each and every steps together. Okay. So for example, first we will be developing trip generation. How we, what are the methods used for developing trip generation? Then we will be looking at trip distribution. What is the logic behind distributing this trip? Okay, how we are going to synthesize? Because in general, what we are having this information that 100 trip are starting, but how to balance this 100 trip so that we have this understanding that 50 should go here, so remaining 50 will go here. Somehow we have balanced it, right? Based on what logic we have balanced it? Right now we have only 3 zones, but if there are 100 zones, because the overall study area, to give you an example, that only Greater Mumbai, which is of somewhere around 450 square kilometer area, is divided into more than 500 zones. So can you do this sort of calculation of balance related calculation for 500 different combination? It is very difficult, right? You have to introduce certain logic into your modeling, right? How we are going to introduce that logic? What are the indicators based on which you are going to define your logic, right? So that is what we are going to look into detail now. For each and every step, how we are going to calibrate the model for each and every step, okay? So firstly, coming to the exercise, first task that you have to do is you have to divide your study area, okay? How to divide your study area? First, you have to divide your study area based on the logic that you are firstly covering the whole study area. For example, if I am doing a 4-stage travel demand model for Vijayawada city, so I have to identify which are the important part that I have to consider in my study area, whether the outskirts of the study area should be considered or not. For example, airport is relatively far from here. So should I consider airport area also as the part of the Vijayawada city? Yes, I have to consider, because a lot of trip exchange are on daily basis are happening between the city and the airport, right? Is there any commercial hub outside the city, right? So I have to consider that because of the e-commerce activity nowadays that we are seeing. A lot of people or delivery partners are traveling from that warehouse to the central part of the city, right? So again, that I also have to consider. So firstly, you have to identify the external cordon lines, right? External cordon lines means external boundaries that you have to identify. Then you have to develop or make sure that all the data or all the boundaries that you have considered are collecting all the characteristics that are needed for your 4-stage travel demand model, right? For example, if there is some area for which the data is not available, so are you going to consider that study area or as a part of your study area? No, because you need important indicators to do your predictions, okay? So normally, once you have identified this is your study area or the outer boundary, now what the next exercise is to divide this study area into small zones, okay? And in transportation we call it as like traffic analysis zone, TAZs, okay? When you divide this whole bigger study area, let's say if I divide this this is Vijayawada, right? So I'm going to divide again Vijayawada into small parts, okay? And those small parts are known as zone, and in transportation literature they are known as traffic analysis zone, okay? So based on what logic you should be dividing your zones, right? So how you what do you think? What based on what logic you should be dividing your zones? Population, population density, okay. Population, major roads, okay. Other than that, land use based on what? Mixed land use. You want mixed land use? homogeneous. What is the problem with having mixed land use? You need to get more data. Okay, other than that, what is the problem with mixed land use? Hmm? So your campus is a mixed land use, right? Because inside the campus you are staying, then your classes are also inside. I'm assuming there might be some, eateries and mess area, some restaurants, right? So as such, you're not traveling outside campus, right? Are you? Or relatively less? Like relatively less you're traveling, right? So what is the problem actually if having, if a zone has a lot of mixed land use? Not problem, it's actually good to have mixed land use in development, but from modeling purpose, what is the problem? Hmm? The major issue with modeling purpose, if you have a mixed land use of a zone, it is very difficult to monitor the intrazonal trips within the zone, how you are making trips. We can model as a analyst the activities or the trips that are happening between two different zones, right? If it is a mixed land use, then what happens? You're traveling within the zone, and it is very difficult for me to model those type of trips because those trips are very short in nature, right? So if I'm asking you how you're traveling inside campus, so you might not be able to report it, right? How I am traveling inside the campus because they are not a significant part of your daily travel. But if I'm asking you how you're traveling outside this campus, those trip information, you can easily report it to me. For example, I'm traveling by public transportation. I have to spend 40 minutes of travel. I have to spend 100 rupees for traveling from this point to that point. I travel because of this opportunity, so on and so forth, right? But the way you're traveling inside campus, which is very small, you yourself are not giving importance to it, right? So how you are going to report it to me, and how then I'm going to model it, right? So it is very difficult for me to model the trips that are happening inside the campus, but I can very easily model how many trips are going to be exchanged between the campus and, let's say, between an area which is airport. That is relatively easy for me because everyone will report to me that on an average in a month how much time they are going to airport or to a railway station, right? That depends on the number of holidays, so on and so forth. On, I can assume a rough estimate of every 6 months you are making 2 trips or 3 trips to your home. That means 2 times or 3 times you are going to airport or railway station. That means if the total student population is 2000, the total number of trip within 2 months will be 2000 into 2, that is 4000 trips. Now it's an easy exercise for me to do, but it is very difficult for me to model that how many times you are going to classes or not, right? Because your friends are putting proxies and you are reporting that you are coming to classes. So it is very difficult for me to perform that exercise, right? To monitor within the campus or the intrazonal trips that are happening. But that is only feasible when you have a mixed land use, because you are traveling for your education within the campus, you are traveling for your food within the campus, for recreational also you're traveling within the campus, right? So that is why the first basic requirement of uh, zoning is you should zone an area, or you should divide the area in a way that they tend to have similar socio-demographic characteristics and similar land use. Okay, so meaning this: if this is a residential area, I will consider this as a zone together. Why? Because my basic assumption is that the way people are traveling from this area is more or less same for all other individuals staying in this area. For example, if I've collected data from 100 people from this area, and the population of this area, let us assume it is 10,000. 10,000 houses are there in this area. I can have this assumption that the way 100 people are traveling is more or less same the way 10,000 people are traveling in this area. And why my assumption is true? Because they have same land use or same characteristics, right? Household related characteristics, it can be socio-demographic related characteristics, the way people are working, right? So for example, if it is a residential area and mostly IT sector people are living over here, so I know now that okay, it is a residential area, mostly IT sector people who are working in the IT sector are living over here. Now whatever information I'm having for 100 people, I can easily predict it for 10,000 people, right? But if this is not a homogeneous area in terms of land use and socio-demographic characteristics, meaning this is residential plus commercial plus educational, okay? Now modeling or assuming what 100 people are doing is same for 10,000 people is not going to be true, okay? Because people who are, who are coming over here for residential for commercial activity is different. People who are coming over here for educational activity is different, right? So that is why that assumption will not hold. So first thing that you have to understand how you have to perform zoning or dividing your study area is to ensure that your zone should have homogeneous characteristics in terms of population, in terms of land use, in terms of socio-demographic characteristics. Okay, okay, this is first what do you call logic based on which you are going to divide. Second would be second would be second would be minimizing error related to aggregation. What do I mean by minimizing error related to aggregation? So here I have collected data from 100 people and I'm predicting it for 10,000 people. Now in general, what is my basic assumption is for 100 people, I will tell that out of 100 people, 50% of the people are traveling to this zone, which is, IT sector. Okay, this is a uniform commercial area, and 100 out of 100 people, 50 people are going to this zone. There is one another, IT sector, IT park over here. So nearly 40 people were going to this IT zone or part, right? And rest 10 are distributed in throughout the study area, right? Now the same proportion, indirectly what is the proportion? 50% of the population is going in this direction, 50% is going in this direction, and rest 10% are, sorry, 40% is going in this direction, and rest 10% are distributed over the study area. Let's say this aggregation is not true. So what will happen? This 100, or there is an error in this 100, right? Or basic assumption behind my logic in this 100. This error will get aggregated to 10,000 people, and the output generated will be having higher error in your model. Okay, so that is why the error aggregation should be minimum, meaning whatever you are performing on 100 people, which is having very less error. So it is good that if you perform this on 10,000 people, again it will have less error. But for 100 people itself, you are having very high error, then it won't be a good exercise to perform it for 10,000 people. Yeah. Break. Okay. Okay. Lastly, in addition to this, whenever I'm combining 3 or 4 different zones, for example, this is my study area, and I have decided this as one zone, this is another zone, this is another zone, this is another zone, this zone is another zone, this is another zone. Okay, so in general, let's say similarly there are n number of zones. In general, I have to ensure that, let's say how many zones are there in this? 1, 2, 3, 4, 5, 6, right? So this boundary of this zone which is on the outer part of this consider, should match with the ward boundaries. So you have existing ward system in the city, right? So let's say if your ward boundary is like this is ward A, so you cannot have a zone which is something like this which lies between ward A and ward B. So if you want to have a zone, you split this zone. So this is will be another zone, and this will be another zone which will be falling in ward B, right? So in general, what I've done, this outer boundaries of these 6 zones are falling, all are falling in ward A. So a zone is not sharing the boundaries of 2 different wards. And why it is important? Because when we are doing, prediction, or when we are doing modeling, we are assuming that there is certain population in this zone, this zone, this zone, this zone, this zone, and this zone, right? All the 6 zones ka population we are using or predicting. The basic assumption is how we are predicting, because government of India or state government is not providing you data related to zone level population. What they are giving you, they are giving you ward level population, right? And what you are doing in this ward, you are assuming that 10% of the population is distributed, okay? But if you have created a zone like this which is crossing the boundary of 2 different wards, so here what you are going to assume and here what you are going to assume will be a problem, right? So that is why you avoid developing a zone in between 2 ward boundaries, okay? Because the population, sum of population of this whole 6 zone should be equal to ward population A. Same thing is true if sum of other, 10 zones in ward B should be equals to the ward population or the total population of ward B. That balancing you have to do. But if you have a zone where, in between, then which part of the population will fall in A, which part of the population will fall in B, will be a difficult answer for you, and that will be an additional exercise for you to do. And it's a tedious task. So why you have to get into trouble unnecessarily, right? So you develop your wards, or sorry, your zones in a way that they match with the existing municipal boundaries or the ward boundaries. Okay. So based on these few logics, you tend to divide the study area. Homogeneous population, homogeneous land use, right? Homogeneous socio-demographic characteristics, aggregation should be minimum, and they should match with the existing ward boundaries. Okay. Smaller is better, meaning in terms of, because if you're modeling at a smaller micro level zone, you are going to get better information in terms of prediction. But we know we have limitations, that if we have very small spatial units or zones, then the computational efficiency required to run or develop OD metrics, 4-stage travel demand model, will be huge. Okay. So on an average, for example, it is assumed that it is always better if you have zones which are, within this 1 kilometer square area. That is the traditional assumption you can have, and that is how you can divide the whole study. So is it clear to everyone? Okay, now we will take some 5 to 10 minutes break, and again we will start. Okay, thank you. Thank you. once we have divided the whole study area into different zones, let us see some of the data requirements. So screen line, we saw the application, we have discussed the application of screen lines, right? We are going to use screen line survey or screen line data for validating our model, right? River, for example, we took the example of river, right? For validating, or railway station, railway lines, right? Coordinate stations. Now, in addition to this, for example, once we have identified that this is our study area, so our basic assumption is this is the exchange of trips, right, in the study area. Okay. But there is one more additional information which is needed to us, which is the trips that are coming from outside the study area to inside, right? So for example, if I tell you that there is a bypass which is going like this, which will be a part of the study area, right? Now there are trips that are coming out using, or buses, car that are using this particular road, they are coming in the study area and they are leaving. So this type of trips are known as external to external trips. What we are modeling? We are modeling internal to internal trips. There is a possibility, for example, I have came over here. So I have come from external to internal. Actually, I am not doing my daily related travel in Vijayawada, right? I've came here just for a single day. So whatever trips I am contributing, or people like me will be contributing in this study area, will be external to internal, right? So how to identify? Okay, we may end up developing models for internal to internal exchange between different areas, zones, you know. But how to identify this external to external trip? Because eventually what is happening? Eventually this is putting a load, this external to external trip is also putting a load on your existing infrastructure of your city, right? So what will happen? Let's say if you don't consider this case, this is your study area, this was your bypass, right? And you have modeled the trips only for internal to internal, from one zone to another zone which you have considered in your study area. And based on that, you saw that your model is telling that here there is no congestion, no congestion, or the V by C ratio value is very less, 0.5. Okay, for this highway, V by C is equals to 0.5. This is what your model is telling. But you know that since this is a bypass, there are a lot of trips or a lot of trucks, buses are coming. They are going from external to external, but they are using this road, this part of your road. And suddenly you saw, okay, actually my model is telling there is no congestion, but actually in reality there is congestion. That means I am missing out on something. And what is that information? That information is external to external trip, right? So how to incorporate that into your model is also important, right? So for that we end up doing coordinate, okay, coordinate counts and identifying which are the points of your coordinate counts. So this point will be your coordinate counts in your study area, because this at this places you will be identifying how many trips, one, are going from internal to external or coming from external to internal. Secondly, how many trips are going external to external. Okay, and these many trips or proportion related to this trip you will be adding your existing trips that you have modeled using your 4-stage travel demand model. So using your 4-stage travel demand model, you got that the link flow on this is, let's say, 5,000 vehicle per hour, and you will add additional external to external trips because you have collected some data, you have some information that on an average during peak hour, you know, 600 vehicles per hour are actually coming on this road, which is external to external. So actual load that you will be seeing on this link will be 5,600 vehicle per hour. Now if you validate it, you may get correct results, or the output will be relatively correct, okay, from the field observation. Okay, so this is the purpose of your count or coordinate counts. So those points you have to also identify, which will act as a connection point from your study area either to the external part of the region, or from the external part of the region to your study area. Those will act as an influx, and those trips are, although they are not high in nature, meaning there will be limited number of trips, but particularly external to external trips are very significant in nature when we talk about big cities like Mumbai. So we know that if you see the map of Mumbai, this is Mumbai, let us assume, right? And this is a highway. So we know most of the coastal traffic, they don't want to get into Mumbai, and if they want to move towards the north or Gujarat, they have to take this bypass, right? And if you develop the four-stage travel demand model, just considering, Mumbai as the study area without incorporating this external to external trip, then it will not show any congestion on this highway. But cities like Mumbai, or where we see a lot of spillover impact, meaning from Pune a lot of traffic might be coming and they wanted to go to Surat or Gujarat or Rajasthan, which is the main connecting part to the rest of the part of the India, then you may end up seeing a lot of traffic, and that is why it is important to incorporate all this. Okay. Screen line stations, we also identified that you have to identify a natural boundary in your study area to validate, and those opening points, for example, in case of rivers, it will be bridges. In case of railway track, it will be crossings, right? So those are the point on which you will be collecting data just to validate whatever inferences you are getting from the model are correct in nature or not, okay? And from the field observation, because on screen line you are collecting field data, okay? You are counting how many vehicle are going and crossing this bridge, right? And that you can validate from your model, okay, what your model is telling. Okay, so this is an example which I've shown you, or we have already discussed, right? So here this is external to external, right? This is inter-zonal trip, meaning from zone 6 to zone 2. This is intra-zonal trip, okay, intra-zonal trip within the zone, how modeling or how we are traveling, right? And technically speaking, there can be a possibility of external to internal trip or internal to external trip. Okay, now this this intrazonal trip are something that we want to be minimum, because our model cannot handle this intrazonal trip. So I will give you an example why it is difficult to handle the intrazonal trips. Okay. Surveys or data that you have to collect to run this four-stage travel demand model. First, you have to collect household-based survey, because you have to understand how people are traveling. For that, household-based surveys are designed. You collect data about the household, how they are traveling, or what is their vehicle ownership level. Uh, from that particular household, how many trips on an average are generated. For example, if there are 5 members in the family, right, and of them, like 5 members, two of them are going for work and one is going for education. So how many trips are generated from that household? 3, right? 3 trips are generated. Number of household members, 5, trips 3. So this sort of information you are going to collect and you can develop a very simple association to understand what will be the trip generated by a particular household based on the information of the household, right? So you guys have performed regression analysis before? Have you heard about regression analysis? How many of you have heard? Yeah, so it's a statistical tool that tends to give you or try to give you an association between and dependent variable and independent variable. So in this case, if let's say if I have information about household size, let's say I collected some data, okay, household 5, 3, 6, 2, 7, 4, 5, 3, and this is trip 3, 2, 3, 1, 4, 2, 3, 2, 6. And I tell you to develop a regression line for this data. So what will be your independent variable and what will be your dependent variable specifically for transportation related problem? Firstly, you understand what is independent variable, what is dependent variable, right? So it will be y is equals to mx plus c, where y is your dependent variable, x is your independent variable, right? In this case, what will be y and what will be x for this case? Sorry, number of trips will be y and household size will be x. Now tell me, based on what logic you have said that number of trip will be y? Can I do this like this? Because this is nothing but y is equals to mx plus c, right? So this will be y minus c by m equals to x. If I solve this, right? So I can say x equals to y by m minus c by m. This is nothing but you have just replaced your equation or solved this, right? Now in this case, why I am not assuming x as number of trips? Hmm? Sorry? Sorry? Trips is dependent on household. So basic logic behind this is when I say y is a dependent variable, right? Y is a dependent variable, that means y is an outcome of x, and x ka hona na hona does not make sense, right? You cannot predict whether x, or you cannot model whether x is there or not. But what you can say, if x is there, then what will be the outcome related to y, right? Meaning you are telling that I am not bothered about the prediction of x. Either it will be given to me, it will be there with me, or it will not exist, right? I'm bothered about the prediction of y because measuring y directly is not easy task. Okay, whereas measuring, let's say if I tell you that in future Amravati, for example, you want to develop a model for Amravati number of trips. Okay, so are you going to assume that okay, the number of trip in Vijayawada is this much, so for Amravati it will be this much? Well, will it be a logical, association or understanding to understand number of trips? No, right? It is better that what you do is you predict firstly what is the relationship between number of trips and household. Then you ask policymakers that what is the composition of household that we are going to see in Amravati. You provide me that information, or let's say you will tell that the average household size in Amravati will be somewhere around 4.4, right? And like this, there will be 1 lakh houses. Okay, so now I can easily monitor number of trips exchange will be I have this equation. Let's say the coefficient of this is coming out to be 1.5. Okay, so I will get 1.5 into household size is 4, and how many household are there like this? 1 lakh. So I will get an estimate that how many trip exchange are going to happen in Amravati, right? Although Amravati currently is still in planning phase, but I can predict because this information will be provided by me to the government. People who are going to migrate to Amravati, 1 lakh household you may end up seeing in, like, let's say next 10 to 15 years in Amravati, right? And the average household size that you can assume that would be same as of Andhra Pradesh. What is the average household size in Andhra Pradesh? Let's say this is again 4.4. 1 lakh similar households will be there. So I can predict number of trip exchange happening within Amravati, right? So although that area is currently still developing, but I can predict based on logical association or the data that I have collected for some other part of the study area, that is Vijayawada, I can still predict what will be the trip exchange. Okay, and that is why you tend to collect data in a way that somehow you can monitor or you can assess your dependent variable based on an independent variable, which is a planning variable normally given by the government. It might be population, it might be GDP, right? It might be household size, because we have this trend or we have this understanding how the population will grow over time. So if you say after 10 years, Amravati city will be developed, altogether developed. So in 10 years, what will be the population growth? That information will be there with me, which will be provided by the government. I can predict number of trips, right? So that is why you have to understand, or the data that you are going to capture, collect, right? So independent variable are going to play an important role in terms of your prediction. Okay? And this type of variable normally you either collect based on household based survey, right? You're going to ask people how they are traveling in their household level. You can collect this type of information during the trip. Like, let's say you are standing somewhere, in a commercial area, right? There you ask them how they have traveled to this commercial area, what is their point of origin, like from where they have traveled, which mode they have taken, so on and so forth. Okay? You can also collect this data particularly at your destination or where your trip is ending, right? You're standing in commercial area. During the trip, meaning when you're traveling with them in the bus, you're collecting information from the user, like from where they have started their journey, right? To which destination they are going. What is the cost of this travel that they are currently facing? Okay? You have to collect data related to land use surveys, meaning either you have to rely on development master plans of the city or the urban area, collect that information from the authorities and try to predict how the land use pattern will be developed, because that will be going as an input for your post-stage travel demand model. Surveys at transportation inventories, for example, toll plaza, right? You can collect this information also from toll plaza, like from where they were traveling, right? What is the average occupancy? For example, if I have this idea that 10,000 people are going to use car, I need one more understanding to convert this 10,000 people to number of cars. What? Average occupancy, right? What is the average occupancy that is observed in Indian condition in cars, right? If the average occupancy, meaning 2% are traveling in a car, so that will translate to this 10,000 trips by car will be translating to 5,000 trips, right? By car, this 10,000 car user will be translated to 5,000 trips. So that average occupancy data you can collect from toll plaza, right? Well, they are paying their tolls and all, you can just have a look that how many people are there in the car, how many people are using car, and you can estimate or get an estimate about that understanding. Also, you can interact with them, collect data related to from where they are traveling, to which part of the city they are traveling, what is the travel time that they have faced, so on and so forth. Okay. Then transportation system performance surveys, meaning whenever you're developing all the 4-stage travel demand model, there will be certain assumption, right? For example, uh, if I tell, or if I'm going to discuss that, from this zone to this zone, this many trips are distributed. That is based on certain assumption that what is the travel time from this zone to this zone. So that travel time, from where that travel time is coming, I'm performing certain performance assessment of the existing transportation system. Actually, I'm traveling on this route and I'm collecting data. What is the travel time that I have faced, right? What is the traffic, actual traffic that I have seen, right? That information I'm feeding, and based on that I'm giving that, okay, from traveling year to year, these many trips will be distributed and this is the travel time, that is what they are going to face. Okay. Is it clear? So what sort of information is needed while data collection as a whole to run a 4-stage travel demand model? And a 4-stage travel demand model, you need actually a lot of comprehensive data, right? It's a very I would say expensive exercise, and that is why you will end up seeing that not every 5 years you are developing 4-stage travel demand models. Once you have developed it, you will be running the model for at least 15 years or 20 years, and slightly you will be revising your model based on some additional data that you have collected over time. Okay. Demographic survey and socio-economic survey, this you will be collecting from the reports like census reports or economic survey reports, that how a particular area is growing over time, what is the population growth in different zones or different wards, that sort of information. So here this is an example of how to actually develop a questionnaire. You guys can look into it and just get an understanding that if you want to develop a questionnaire, what sort of information you have to extract. Now let us understand some basic definition while for developing 4-stage travel demand model. Number one is trip. Trip is nothing but a one-way movement. For example, if you are going from here to your office, it is counted as one trip. Okay. Home-based trip. Now it is important. Home-based trip is, if let's say if I'm going from this place to my office, right? This is a home-based trip. Why? One of my end of the trip is actually attached to home. If I'm coming from my office to home also is a home-based trip, because one of the end of my trip is attached to home. Okay. Non-home-based trip, if none of the trip ends are attached to home, right? For example, from your workplace to shopping is a non-home based trip. Okay. And normally why there is a need to differentiate between home based trip and non-home based trip is a lot of proportion of trips are actually what we are observing are home based trip, meaning people are traveling from their home either to job, either to education, either to shopping, recreational, so on and so forth. Very less amount of trips we are going to see which are non-home based in nature. Okay. Trip production is nothing but overall when you do the analysis for home based trip, right? How many trips have been produced from that particular area, then you call it as like trip production. Trip attraction, that is specifically dedicated to how many trips are being attracted by an area, that is actually associated to a non home based end, trip end, right? Either commercial area, educational area, which are not home. Okay. So houses are always going to produce. Okay. Shopping, commercial area, recreational area are always going to attract. And trip generation is nothing but it is the total idea about total trip production and total trip attraction. Okay. So trip, as we have seen previously, that if there are 3 zones and I have identified that this is attracting 50 trips, this is producing 100 trips, and as such 0 trips are produced by this zone. So we have this understanding that out of 100, 50 will be gone over here, right? Remaining 50 will go over here, right? And this is how we have balanced it. So this whole exercise of getting 100 production, 50 attraction, and 0 production and 50 attraction is based on your trip generation model. Okay. So for every zone, what we are going to do, we are going to identify how many trips it is going to produce. For every zone, we are going to identify how many trips it is going to attract. Okay, we are going to develop equations. So trip generation in general, from the home it will start. You may end up doing a lot of trips related to different destinations, right? And based on that, we quantify it as like trip generation. Now this is a general idea about within the home based trip. We further classify different type of trips. Normally compulsory trips, meaning for which you are traveling on daily basis, right? And other trips which are not compulsory in nature. For example, your social recreational related trips. So you're not actually traveling on daily basis. Sometime you end up changing your plans. Let's say, for example, you are occupied with something, right? So you end up giving up on your some of your recreational trip or some of your social trip, right? Whereas if you are occupied with something, are you going to miss out on your work? Not really, unless and until it is very important task, right? Are you going to miss out on your schools, college? Not really, right? You are going to perform your mandatory trips or compulsory trips. So, particularly work and education related trips are compulsory in nature, right? Uh, Shopping, if we talk about specifically shopping, nowadays, previously, shopping used to be in between, compulsory and sort of not mandatory trips. But nowadays, shopping is more about not a s- not very much compulsory trip because of the online options that we are having, apps and delivery, so on and so forth. So what we end up doing is like, if you don't feel like going, you order things online, right? So so basically, we will be monitoring, and to give you just a context or just basic idea, nearly 75% of the trips, home-based trips, are associated with work and education, right? Rest 20-25% of the trips are associated with other types of like, shopping, social, recreational trips. Okay. So it is of importance. What is of importance? Particularly modeling, work-related trips and education-related, right? Non-home based trip, which we have discussed. What is non-home based trip? When you're traveling from your workplace to shopping, when neither of your trip ends are associated with home. Okay, it is not a right? So trip rate means you have to just identify or analyze trip rates. Okay, some information will be given to you either based on population, either based on land value size, either based on area, and that will give you an information that that particular area is generating so many of trips, right? So on an average per unit rate you have to understand. So what is the trip generated by one population? Okay, so this is a very simple method. Now once you have this trip rate of 0.8, what you can do, you can apply this trip rate to different part of the study area, because you will have an understanding that this study area has a population of 2000, right? Trip rate is 0.8, so 1600 trips will be generated, right? This particular part has a area of 5000, so how many trips will be generated? Which will be 4000 trips will be generated. So on an average you will get an understanding. So this is a very simple and a basic approach. Okay, next is cross classification. Now cross classification is a slightly better method than the trip rate analysis. In cross classification what will happen, that here the basic assumption what we are assuming, that all the 1000 population are generating 800 trips, right? So instead of that, what cross classification will do, it will sort of identify number or trip rate for different category of population. So what I will be doing, this 1000 population I will be dividing it to different classes. Okay, low income class, moderate income class, high income class, and this 1000 population is divided into three classes. Let us assume, okay, low income classes of 500, meaning the population nearly 500 population is low income class, 200 or 400, and high income class is 100. Now for this each category of population segment, how many trips are generated? So here let us assume for low income class it is 200 trips. For high income class, let us assume it is 200 trips, and sorry, moderate income class it is 200 trip, and for high income class it is 100 trips. Okay, so here what we will be identifying, for each of this segment we will be identifying the trip rates, right? So here the trip rate will be 200 divided by 500, 2 by 5, somewhere around 0.4, right? For here it will be 0.5, right? 200 divided by 400, and for this case it will be 1. So did you observe a trend? As the income increases, the trip rate also increases, and that makes sense also, right? So instead of assuming a homogeneous income or homogeneous population of 1000 and assuming a point rate trip rate, or a trip rate to be 0.8, now I have done a classification based on categories or different categories, right? Now what I can do is, like, the government can provide me information that what percentage of the people are falling in low income group people, what percentage of the people are falling in high income group people, and what percentage are falling in moderate income group people. I can use that information, number of households in this category, and I can use this factors, and I can predict what will be the number of trips. Okay, so this is a more advanced or a better, slightly better way than the average trip rate based method. Okay. Next is simple regression, right? We already have an idea about regression, right? How does regression work in general? In simple regression, what we will be doing is, we will be collecting data related to number of trip and capturing some of the socio demographic information, right? For example, whether they have a car or not, how many cars they are having, right? What is their income level? What is their education level? How many members are there in the family? And we will develop a equation which is number of trips at a household is equals to a function of, let's say, C, which is constant, plus alpha into number of car plus beta into number of members plus delta into income, right? Once I have this information about this coefficient, can I predict the number of trips generated by a household, right? For example, what I will be doing, I will be asking the characteristics from you, right? Do you have a car at home? Let's say you answer something, right? Yes or no. Then I will be asking how many family members are there in your home, right? Then I will be asking what is the average income level, right? Let's say if it is 80,000, 90,000, that I will be inputting over here, and I will be getting that your household is producing, or number of trips generated from your household is this much, right? This information I may get or end up getting from the government also, that what proportion of the population is having car, or what proportion of the household is having car, what type of income group people are there in different category, right? And what is the average household size. Based on that I can predict number. So for this area I can predict, for that area I can predict, and overall what I will be doing is I will be predicting number of trips generated from each part of my study area, right? So first I will be doing some data collection. Using that data I will be developing this regression, simple linear regression equation, and I will be predicting for each of the zone how many trips has been generated. So is it clear how to perform a trip generation model, or how to develop a trip generation analysis? Or okay. In addition to this, nowadays because of machine learning algorithms and non-linear association, you can also develop more complex model, regression model, like non-linear regression model, and try to understand how the trips, number of trips, are affected because of different socio-demographic variable, or different individual related variable, or related because of the system. Okay. That completely depends on the complexity that you want to involve in your models. For policy making, we have to understand, for policy making you have to develop very simple models. Why? Because you have to also understand that we have to do predictions for the future, right? And if your model is not simple, and if you don't have simple independent variable, then how you are going to predict for future? Okay. For example, if you have developed a trip generation equation, okay, which depends on uh, on something which is not measured for future, or which is difficult to measure for future, for which we don't have prediction. Okay. uh, let's say number of retired family member in your household, that sort of data is not there with the government, and it is very difficult to predict that sort of data, right? So in that case you should not use those variable into your model. Somehow you have to make your model very simple, which is number of family members or population, and number of vehicles, because vehicle ownership models or prediction related to vehicles are available, population related prediction are available to you at zonal level, or at ward level. So very easily you can get that sort of prediction, or that sort of understanding, right, for the policy makers, right? But for research purpose and all, you can look into different aspects or different factors that contribute toward trip production. Okay. So one by one, quickly we will see. For example, this is a trip rate analysis. Here what we are doing is different type of house type, meaning row house and apartment, right? What is their area, how many percent trips are generated, and you just find out the rates, right? Trip per 1,000 square meter area, right? Same thing for commercial activities. So this is generation. Next is commercial activities are associated with attraction, right? For commercial activity, what is the land area, how many percent trips are generated, you identify the rate. Okay. Public building, what is the area available of the public building, how many trips are generated or attracted, sorry, and you identify that. Now once you have this, what is the total area? Now if you want to predict for some other zone, you have trip rate, you have the information about the other zone, that how many row houses are there, how many apartment houses are there, right? What is the commercial area available in other zone, right? And what is the number of public buildings available? You can use that information, you can use this rates, and you can predict the number of trips. Is it clear to everyone? Now cross classification, right? So what I have done over here, that for different spatial regions of my study area, meaning people who are living in CBD, center part of the study area, central, business district, people who are living in inner side of the study area, and people who are living in the outskirts of the study area, right? For those people, I've identified what will be the vehicle ownership, right? I've differentiated that data in terms of different vehicle ownership, and I've modeled the trip rates, right? So I've done further classification, meaning if you see vehicle ownership 0, 1, more than 2 or equals to 2. For those people, if the household size is 1, how many trips they are generating? For those people, for example, in this category, if you see person who is staying in the CBD, okay, he has more than 2 cars, or the family who is staying in CBD has more than 2 cars and is a single individual. So can you see the trip rate? It is 1.82, significantly high. So that means an individual is making 2 trips. That is, one, he or she might be going for job. Second, he or she might be going on daily basis for grocery or shopping related thing, right? Whereas in this case, if you see that although the number of family members are uh, 2 or 3, which is thrice, you can assume, but still the trip rate are slightly lower, right? In magnitude wise it is higher, but if you relatively see, 3 members are producing how many trips? 3.9 trips, whereas a single member is producing somewhere around 2 trips, right? So you have further classified that information, that vehicle ownership, how vehicle, so here if you see in general, that how vehicle ownership tends to increase your trip rate, right? That information you have incorporated in your model, yes, because a trend you are seeing, as the number of vehicle increases from one class to another class, the trip rate is going to go high, right? So if it is nearly 0.5, it is going to go high to 1.4, and then it is going to go high till 1.8 or nearly 2, right? So this actually gives you an idea how vehicle ownership tends to increase the trip rate. This column will give you an idea how household size is going to impact your trip rate, right? Now this sort of information, how many people are staying in CBD household, that you will get, right? In the CBD only itself, how many household have 0 car, 1 car, 2 car, that also you will get, right? How many household have a family member 1, more than 2, 3, and 4, that also you will get. So very easily you can predict it for any zone, what will be the number of trips generated. And it's a more robust way rather than just simply assuming commercial area, land area, house size. You are actually dealing or getting more minute level of information to predict the number of trips, okay? This is an example of doing a regression analysis, right? So here you can see that we have done number of trip by an household. If this data I have collected using a household survey, which says what is your household, like members in your house, 3, 4, 5, 2, this you have collected. Number of car, whether you have a car, 0, 1, how many cars you are having, right? And how many trips you are doing on daily basis, right? So using this, I can develop a simple linear regression model which says that number of trips by an household is equals to 2.12 plus 0.4 into number of members plus 2.06 into number of cars, okay? And you can very easily predict, right? Now for a zone, this information will be given to you, that how many household are there having size 2, 3, 4, so on and so forth, right? How many households are having car? 3 households are having car, or sorry, if there are 1,000 households, 30% of them are having car or not, right? That you will just use as an input and predict how many trips will be generated. So is it clear to everyone how to perform trip generation related modeling? Same thing you can do for trip attraction. So trip attraction per zone, this I've just given a simple example. How many employment they are generating? So I'm telling that it is 2.4 times into the number of industrial workers actually placed over there, right? So every zone will have this information, that how many industrial workers are there, how many retail workers are there, how many IT related workers are there, so on and so forth, right? Or commercial workers are there, and you can predict how many trips a particular zone will be attracting. So is it clear to everyone about the trip generation? So we have completed the first part, trip generation, right? Now in the next session, should we take a, yeah. So in the next, we will be discussing quickly about production, mode choice and traffic assignment, step by step. And then in that way, we will be covering the whole 4-stage travel demand. Okay? Yeah. Okay, thank you. Start. So the next aspect that we are going to discuss is trip distribution. Okay. So trip distribution is nothing but it tends to give you the linkage or understanding that if so many trips has been generated, where they will be distributed over the space or over the study area, right? And just by this example, as you can see, let us assume this is a residential area, and in that, 7 people are there for which the trips is generated for all the 7 people. Now someone wants to go to school, college, someone wants to go to factory or some industrial area, someone wants to go for a shopping, someone wants to go for a recreational trip like park, someone wants to go for an IT job or something. So eventually what we have done is we have redistributed all these 7 generated trip in different part of the study area. Okay, and this is what we are going to do with trip distribution. Once you identify these many trips will be generated, now you have distributed them over the space. Okay, this is the traditional output of trip distribution, meaning if I want to develop my output of trip distribution for different zones, so what I'm doing is I have given a nomenclature with an ID which is zone number. Okay, so from zone number 1 to zone number 2, how many trips will be going, right? So this is what we want in general, right? Now here if you see that the row sum, right? Sum of the rows or the values in, if you sum all the values in this row or the first row, what it is giving you? T11 plus T12 plus T13 plus T14, so on and so forth, right? So this is giving you summation over T I I j, right? If you sum all the observation in the first row, right? So this is actually giving you the productions. Am I right or not? This is actually giving you the production because these many trips has been originated from one and they are distributed to different part of the study area. 1, 2, 3, 4. And if you sum all these trips which are distributed from or starting from 1 and distributed to all the other part of the study area, which I am doing over here, sorry, over J, which I am doing over here, I will get total number of trip produced from I, right? Same thing is true for column, sum of all the columns, right? For specific column, let's say if I want to identify how many trips has been attracted towards zone 1, so what I will be doing, how many trips are coming to 1 or to I from all the possible combination of J, right? And this I am summing over I, then I am going to get the attraction, right? And we have already developed the equations. We have already developed the equation for productions, Pi and Ai. What is Pi? Pi is number of trip starting from zone I or zone 1. I is number of trip attracted by zone 1 or zone I. So we have already developed the equations for this. You can easily run a regression, try to find out how many trips has been attracted by zone I. This will give you a regression about how many trips that has started from zone I, right? Using regression analysis, the first stage of your travel demand model, that is trip generation, right? Now we have to, so these values will be there with us. These values will be there with us. Somehow we have to identify the values in these cells, right? So if you see this particular matrix, so we have been provided with these values, meaning total number of trip produced by zone 1, this value is there with us. Total number of trip produced by zone 2, this is there. Total number of trip produced by zone 3, it is there. How many trips has been attracted by zone 1? That is also there using the regression equation that we have developed. Same thing is true for 2 and 3. Somehow we don't have information about these cell values, right? So there will be 9 components which we need to fill this particular matrix, right? Now, based on what logic we should develop our model so that somehow we end up getting this 9 values based on these different values. Okay, these are 6 different values which we have. Somehow we have to develop this matrix in a way that these 6 values can be utilized to develop all the 9 values. Okay, so what is your logic? How do we do this? So normally if you talk in terms of maths, let's say if there are 3 equations, 3 variable, right? Can you identify x, y, z? Yes, if you have 3 equations, 3 variable. But here the problem is you may have 6 equation, but how many are changing over here, or how many variables are there here that you have to identify? That is 9. So it cannot be solved directly, right? We have to use certain intuitions and apply those intuitions and then get the cell values. Okay, and this is the output of your trip distribution. Okay, so based on what logic actually we develop this sort of matrix? That is the main question. So there are different ways on which we can, or based on which we can understand that which logic we should apply in order to get these matrix or these cell values. Okay, one part is we can divide them broadly into 2 different categories. One is growth factor based analysis, another one is synthetic methods, meaning you use certain complex understanding of how people are traveling, use those intuition and develop it, right? So growth factor method is a very simple method in which you assume certain rate of growth. Let's say what I will be doing, that I will be assuming what is the proportion of trip that are attracted by 1, okay, or what is the proportion of trip that are going from 1 to 2 is the overall proportion of the trip that are being produced by 1. I can assume certain proportions, 5%, 10%, 15%, 20%, right? And I can redistribute them. So this is a simple growth based method where which can be used for trip distribution. It's a very simple approach, right? Same thing is with average. In average what you are doing is, what is the growth rate we are going to assume for the origin point and what is the growth rate we are going to assume for the destination point. Take the average of both these things and you apply that factor and develop the matrix, right? So for example, if you know in future this particular area, or this particular spatial unit is going to grow by, let's say, 50%, right? Meaning if current state is 100, then it will be 150 number of trips, right? So what you are going to assume, that by 150% we are also going to increase the number of trips, right? Now in average growth method you are also going to identify, let's say from this area the growth is 50%, and where it is distributed, or where we are aiming to distribute these trips, the growth is, let's say, 25%. Now you will take average of 50 and 25 to assume the growth. In this case it will be somewhere around 137%, right? So that 137% you will just applying them, multiply them, and you will get the filled matrix or this cell values, right? So it's a very simple method based on basic understanding or intuition. A more robust method is based on gravity model, okay, and we are going to discuss in detail about gravity model. So firstly, this is growth factor method in which we assume a growth factor E, and by which we are going to multiply our cell values, and we are going to get the number of trips that are distributed from 1 and 2. Average growth factor method, as I've said, you assume some growth factor for origin, you assume some growth factor for destination, take the average of them, and then you apply them, and for the future you can predict these many trips will be going to happen, or these are the exchange trips that are going to be seen in 10 years or next 10 years or next 15 years, right? Now the most important method, which is a gravity model, which is highly mathematically robust model to develop this matrix. So what does gravity models tell you? So have you heard about gravitational forces before? In your 12th and all, you might have seen Newton's law of gravitation. So what does that law tell you? What is the fundamental assumptions of that law, or based on which principle it has been developed? So it is two body will attract each other with certain forces, right? That is gravitational force, and that force actually depends on the mass, or directly proportional to the masses of both the bodies, and inversely proportional to the distance or square of distance, right? If these two bodies are very far, then the force of attraction between those two bodies will be very less. If these two bodies are very big in nature, in mass, then the force, attraction force acting on both the bodies will be very high, right? So based on that, Newton has given this equation. F is meaning force between 1 and 2 is proportional to m1 into m2, meaning mass of body 1 and mass of body 2, divided by distance, or d square, inverse relation with respect to distance, right? Now the same logic what we are going to do is we are going to apply in our case, because tentatively if you think what we are doing, we are identifying that how many trips that will be starting from this region and are going to get attracted to that particular region. Now if these two regions are highly commercial regions, or not only commercial but highly active regions, in terms of, when you see activity, that means there will be higher demand for travel, right? If two region, if I say that, the area outside SPA Vijayawada is very active, that means a lot of people are traveling on daily basis, coming over here, right? There might be a lot of commercial activities being carried out very close to the campus, right? If I say a lot of trips has been seen near airport, that means again it is an active region because a lot of people are traveling, right? So the same logic we are going to apply over here. We are somehow going to quantify the activities of two zone, and based on that activity, and based on that activity we are going to identify what will be the rate of exchange of trips between these two zones. Got it? Meaning, if this area is producing 1000 and this area is attracting 800, there are other areas also which are small in magnitude. Let us assume 30, 40, 50. Other areas are producing 30, 40 trips, and other areas are attracting only 10, 20 trips, very less in compared to this. So what will be your assumption? That maximum exchange of trip will be happening between these two zones. Does this sound logical? Is it making sense? That if two activity zones exist, then the maximum exchange of trip will happen between those two activity zones, or those two activity areas, right? Because the other areas are not able to attract so many trips. Same thing is true, the other areas are not able to produce so many trips. That means maximum exchange of trips that you are going to observe will be between these two areas. The other areas are not that important. But what can discourage them to have this trip? Let's say two zones. There are two zones. They are a lot of activity is being seen. A lot of people are staying in one zone, which is completely a residential area, right? And there is another zone which is completely a commercial area, or a CBD. Rest of the study area is more or less vacant, or as such you don't have much population, right? So what will discourage people to travel between these two zones? Based on this logic, most of the trips will exchange will happen between these two zones only, where maximum people are staying and where there is maximum commercial activities, right? But can there be one factor which can discourage people not to travel so far? What is that one factor? Distance, right? So what will happen is, even though these two areas are generating and attracting a lot of trips, if they are very far from each other, right? So the trip exchange will be penalized based on the distance. If they are very far, then whatever assumptions you are having, you have to slightly adjust those assumptions, or you have to slightly penalize the rate of exchange because they are very far. right? If they are very close, then definitely 99% of the trip exchange will be happening between these two zones. But if they are very far, then there will be loss of exchange of trips. Okay, so based on this logic itself, we tend to develop that trip from I to j is a k, which is an adjustment factor, which we have to identify doing an iterative process. Pi is the production, number of trip production from I. Aj is the trip attraction to j divided by distance, or a function of distance. Okay, so somehow what I have done, I've said that Tij is a function of activity, how we are quantifying activity in transportation based on production and attraction. So production at I, comma, attraction at j, comma, function of distance, right? And a very robustly used example is this form of function, meaning production into attraction divided by a function of j. Now that will completely depend upon you, this n, how to get the value of n, right? Those are done based on calibration. Certain calibration you have to perform. Okay, which type of deterrence function? So this whole function, if I want to write, let's say this is f of d is equals to 1 by d square, right? This is nothing but a function of d, which is 1 by d square, right? So if this whole function I want to write, can I write it d to the power minus 2, right? D to the power minus 2. So I can say f of Cij, which is d, meaning distance from zone I to j, is nothing but Cij to the power minus 2, right? So now I will get a functional form of trip from I to j is equals to Pi Aj into f of Cij, right? And we know f of Cij is this. You got it? So based on this functional form, we tend to assume that this will be the rate of exchange of trip between one zone and another zone. Okay, now the whole thing is, I can generalize this. Instead of assume, you can ask me why to assume minus 2. Can we assume minus 2.5? Can we assume minus 3? Yeah, you can assume. That all depends on how you are calibrating this function, and this may differ or this may change based on your study area. For example, if you are talking about Bangalore, right? So in Bangalore, what is happening? On an average, people are traveling a lot. They are traveling for 60 minutes, 70 minutes. So if you see the average travel time, it will be somewhere around 70 minutes, 80 minutes, right? Whereas if I talk about Vijayawada, so Vijayawada on an average, how much people are traveling? Maybe 20 minutes, 30 minutes for their daily activities, right? So in that case, what I can do, I can use the value of n in a way that penalizes distance more. So for, let's say, Bangalore, this n value can be somewhere around minus 2.5, minus 3.5, so on and so forth. Whereas for Vijayawada, where you are not penalizing distance a lot, right? You're not penalizing distance a lot. There you can assume the value to be close to 1.5 or 2, somewhere around that. Okay, so this is how you have to calibrate this functional form of distance. Okay, so based on this logic, we understand what will be the trip exchange between zone 1 and zone 2, or any zone I and zone j, right? Based on the gravity model. Is it clear to everyone? Right? Now what happens is, like, software will ask you what is the functional form of f of Cij. That is something that you have to give to the software. Okay, and based on this understanding, by type of city, or whether previously people have calibrated this functional form or not, you can use the same functional form and tell the software to generate this OD matrix for you. Okay, so the first thing that you did, you identified PIs using regression equation. You identified AJs or AIs using again regression equation. Using gravity model, based on this logic, you have estimated trips also that are going to have or that are going to be observed between zone 1 and zone 2. Okay, is it clear? Now normally what happens is like we also assume one more thing, or we tend to assume that the model should be able to calibrate it. That is the diagonal elements in your matrix. This is matrix, right? So what do you think? What should be the diagonal element in this matrix? Or what is a desired value? For example, if we go back, right? So can you see these are diagonal element T11, T22, T33, so on and so forth. These are diagonal elements. So what is a desired value, or what do you want actually these diagonal values should be? So ultimately this will be numbers, like number of trip exchange between 1 and 2 is 100, 500, 1000, 10,000, so on and so forth, right? Based on the activity of the two zone and how far they are from each other, right? So here what this diagonal element T11 is indicating? Number of trips starting from 1 and ending in 1. That is their origin is also 1 and their destination is also 1. So what do you want the T11 value to be? We have discussed this, right, in the previous class. These are intrazonal trips, and what do we want in intrazonal trips? The value should be 0. As such, because modeling intrazonal trip is very difficult, it might be very short trip, right? So modeling them is very difficult. So our basic requirement is whosoever is planning to travel, or we consider travel as something that they are traveling from one zone to another zone. Within the zone, if they are traveling, that is a very short trip, and as such it should be, you know, not accounted in actual trip making process, right? So this diagonal element, normally we want them to be 0, right? So the model is again calibrated in the same way or in the same fashion. Okay. Now, as previously, why I want, or such type of constraint, why I want in my model is, if you see this equation, what happens to f of Cij? If your distance is 0, and let's say I'm assuming if my distance is 0, so what will happen to the Cij values? Yes, infinite. Then it will create a problem, right? The number of trip exchange, it may show very high. And intuitively thinking, if the f of Cij function is not equals to 0 at function value or cost value 0, then what is the problem? It may end up assigning all the trip in the same zone itself, because this is model, right? Model will work on number based logic. It will tell you that Tij ke beech mein exchange is very high, because as such the distance is 0. So why I not assign all the trip that are starting from 1 to 1 itself, right? So to avoid all those things, we assume that this diagonal element should always be 0, and your functional form should be in a way that have the capability to tackle all this problem. Okay, so we got an understanding how we are going to get f of Tij, that is exchange of trip between 1 and 2. Okay. So these are some of the functional form of f of Cij, or the impedance function. This is also known as impedance function or deterrence function, because by this function only you are going to identify how people are not willing to travel longer distance, right? So there can be different forms of impedance function. One is power function, another one is exponential function also. So if you see, what is the curve of exponential function? How does an exponential or negatively exponential function looks like? E to the power minus x. E to the power minus x. it will be something like this, right? That indicates if your x value or cost value is very high, so f of Cij e to the power minus x value will be very low, and the trip exchange between those two zones will be very less or almost zero, right? Based on this logic, you tend to assume different functional form. Now this functional form either will be provided by the policymakers, either they have already calibrated it. If you don't want to calibrate it, then you have to, use literature and try to understand how to assume different functional forms. You can have different forms, different functional forms for deterrence function. Okay. Okay. So we have firstly solved like trip generation. Now we got the answer for trip distribution as well using some sort of functional form, right? Next step is mode choice. Now mode choice, if you see overall how you guys are deciding upon modes, like this particular mode I'm going to choose for my travel. Cost, comfort, travel time, waiting time, if there is a function of waiting time. So overall in your mind you're doing some sort of calculation, right? And you are just estimating or doing a trade-off, right? And then ultimately you are saying that this particular mode is better for me, that is why I'm going to choose this particular mode, right? For example, if you are starting from your campus, right? So what are the options available to you? One is public transportation, like buses if they are available to you. Second one is walking. Third one, if you are having cycling. Fourth one is auto rickshaw or totos. And if you guys have two-wheeler, then maybe two-wheeler or something like that, right? So what are the options available to you? N number of different options are available, but they are finite in nature, meaning either there will be 5 6 different modes options will be available to you. Now what you are doing indirectly, out of this available options, you are doing a trade-off. The cost of travel by auto is very high, public transport it is very less, but the travel time by public transport is very high. Comfort is not there in public transport, there is no chance of getting seat, it might be crowded, right? Reliability, I have to wait a lot. In autos, only cost is the problem, right? But again, availability of auto, meaning if I go down from my hostel, whether I will get an auto or not, reliability is a problem, right? Right? So if you have cycling, then you end up thinking that, oh, the distance is very far, it's the weather is not good or suitable for cycling, I may not end up doing cycling. Yeah. Okay. Okay. So indirectly here we are dealing with human behavior, right? Meaning every individual is making decision which mode he or she will be using for a specific trip, right? So here we have to collect data related to human behavior, and that is why this particular mode choice related aspect is known as behavioral modeling. Okay, here you will analyze how people are weighing different characteristics of the mode, what are their socio-demographic characteristics, and based on this collective sets of attribute, how you're deciding that this particular mode I'm going to choose. Okay, so here firstly very important stage is how to get the data related to preferences, right? For that you have to understand which sort of survey you have to conduct. You have to deal with individual level data, meaning asking people which mode they are traveling, why they are traveling, what is the travel time by this particular mode, whether this type of mode is comfortable or not, right? So for that you need to develop certain surveys for which you will be collecting responses for different type of mode. Then next is, once you have collected data, your data management and understanding the models related to that data. Okay, so in general this mode choice of behavioral analysis is mostly divided into three different segments. So when I talk about surveys in mode choice, what we are asking people is their preferences, right? What is your preference towards a specific mode? There are two types of surveys that we may end up doing. One is a stated preference survey. Second one is a revealed survey. What is a stated preference survey? Hmm? Yes. So you give, they will state you, meaning you give them some set of options, right? Then you will ask which mode you are going to prefer. Yeah. So one important aspect of stated preference survey is, let's say, in reality, what should I will be doing? I should be I should be collecting responses from people. Okay, which mode you are choosing? Actually, you are choosing this mode, but there were three different modes available, right? And you chose this mode. What was the reason for you choosing this mode? You may end up saying that the travel time was less by this mode, it was more affordable, so on and so forth, right? But let's say if I'm talking about an hypothetical scenario, if a metro is coming into picture after 2 years, are you willing to take metro? So this is an example of a stated preference experiment, where now you're not asking them which mode you are using. Here you are telling them, look, there is a new mode coming into picture. This is a metro. The travel time by metro will be this much for your trip. The travel cost will be this much. The waiting time will be this much. You are currently using, let's say you're using bus or you're using two-wheeler, right? Your travel time is this much. Your cost of travel is this much. So are you willing to choose metro when the metro will be coming in future? And then you may end up responding, yeah, I'm willing to choose metro, or you're not willing to choose metro. In this case, you're stating your preferences, but there is no guarantee that if the metro comes in future, then definitely I'm going to choose it or not. So this type of exercise is known as a stated preference survey. Whereas revealed preference survey, what you will be doing, you will be asking which mode you have used today for this particular travel. Okay, let's say you ask me which mode of travel I have opted today for, let's say, coming to Vijayawada. So I will report you that I have used flight, right? Airline. And so you will tell me that I had two options, either flight or train, and I chose flight, right? But if you want to assess whether in future people are willing to opt for hyperloop type of a mode of transportation or not, does that exist today? No. So what you will be doing, okay, today you chose flight. Let's say after 10 years, there will be hyperloop connections between different cities. And are you willing to shift to an hyperloop system where the cost will be this much, the travel time will be this much, and today's travel time and travel cost for airline will be this much. So are you willing to shift to an hyperloop system? So I may state my preference. Yeah, I may be willing to shift or I may not be willing to shift. Whereas if you ask me and compare today's train and flight, then this is known as a revealed preference survey, where I have revealed exactly to you that my chosen mode or the mode that I have used today is flight, and the option available to me was a train, right? I have chosen flight because of my travel time constraints. I want to reach a particular destination quickly. That is why I have chosen flight over train. Okay. Start. So, so based on the type of survey, there will be different ways in which you collect data, right? For example, revealed preference, the way you are going to collect data is single response from a single individual, which mode you have taken today. Whereas in stated preference, what you can do, you can also perform certain additional exercise, meaning, okay, this is the travel time, this is the travel cost by a futuristic mode. This is the travel time, this is the travel cost of a current mode that is being used. Are you going to shift to, a futuristic mode? I will say no. Okay, now further I have reduced the cost for the futuristic mode. Further I have reduced the travel time. Are you now willing to shift to a new mode of transportation in future? And then I will evaluate, okay, now whatever you are suggesting is attractive mode of transportation to me compared to my existing mode, then I will switch. So from a single individual, I may end up collecting 5, 6, 7 observations. Whereas in a revealed preference, I'm collecting one observation or one response from every individual. Is it fine to everyone? What is the basic difference between a stated preference survey and a revealed preference survey? Okay. Now using this responses or using this data, we can develop different mode choice utility equation for our transportation system. This is based on, like for example, as I've said to you guys, how you're doing your calculation in your mind. You are giving some sort of weightage to a mode which is more attractive to you, and then you are deciding, okay, the overall weightage or overall score of this mode is high. That is why I'm choosing this mode over the other options that are available to me. So in that, what we say, this score is nothing but utility. Okay. Indirectly, this says that you are deriving most of the utility for your travel using this specific mode, right? So your utility is higher for this mode. That is why you have chosen this mode, whereas the utility available for other mode was relatively less. And how do you form the utility? So as I've said, this is nothing but utility u, right? U of mode m is nothing but summation over beta x. Meaning, if I assume certain variables, travel time, travel cost, I will identify this betas for travel time, I will identify this beta for travel cost, I will identify this beta for waiting time. So it can be something like this. It is nothing but a score, right? So beta 1 into x1, beta 2 into x2, plus beta 3 into x3. I will use this beta, I will calibrate this beta, meaning I will find out this beta, x1, x2, x3 are the information of the mode. That is, what is the travel time by the mode, what is the travel cost by the mode, and what is the waiting time associated to that specific mode, right? And interestingly, you will see one thing, that these are known as, this x1, x2, x3 are known as system attributes. Why they are known as system attribute? Because waiting time, travel cost are a characteristics of the mode, right? They are the characteristics of the mode. They are not the characteristics of the individual, right? Are they the characteristics of the individual? No, they are characteristics of the board, right? And for these modes or these attributes, I'm just trying to find out how much important for you is travel time. Based on beta value, I can identify that, right? How much important for you is travel time, how much important for you is travel cost, how much important for you is waiting time, right? And what do you think? What will be the sign of betas in this case? Let us assume x1 is waiting time, x2 is travel time, and x3 is travel cost. So what will be the sign of betas in this case? You are calibrating the model, or you are, you have collected some data and you are calibrating the model. Right now I have assumed beta 1, beta 2, beta 3. But if I'm just asking you what logical sign it should have, so what is your take? Sign in the sense whether it will be negative or it will be positive. Almost negative? Always? Negative, yes. It should be negative. Why it should be negative? Because if travel time increases, so your utility will increase or decrease for that mode? Utility decreases. If waiting time increases, so utility should decrease. If travel cost increases, your utility should decrease, right? And utility is nothing but a score that you have developed in your mind, right? And which is derived from this three attributes. Now these three attributes should be negatively associated to your utility, right? Because you don't want to spend more on your travel. Do you want to spend more? Do you want to travel more in terms of travel time? Do you want to wait more? No, right? So if so, what a logical sign? What logical sign it is expected to have? It is negative, always negative. Okay. And once we have this beta values, what we can do? I can identify utility of car, because x1 value will be different for car. Travel time by car will be 15 minutes, by bus will be, for the same trip, will be 20 minutes or 30 minutes, right? So once I have this beta, I have to only use different modes. So I will get the utility for different modes. For example, you will just tell me that I have calibrated the betas using the response from you guys, okay, which mode you are preferring, right? I've calibrated that beta. Now I can find what was the utility of car for you, what was the utility of bus for you, what was the utility of train for you guys, because I've calibrated beta, right? Beta I have already calibrated using modeling. I only want x1, x2, x3, and we know x1, x2, x3 are nothing but system attribute. Travel time for car will be there with you, travel time for bus will be there with you, travel time for train will be there with you, right? So I can find out utility for each of the modes. Now using this utility, what I can do, I can try to find out probability. Okay, what is the probability that you are going to take car? What is the probability that you are going to take train? What is the probability that you are going to take bus? And there is a simple formula for this, which is probability of car is e to the power utility of car divided by e to the power utility of car plus e to the power utility of bus plus e to the power utility of train. So in this case, if you see specifically, if the utility is highest, right, compared to the other two modes, let's say the utility is 100 for car, and for train and bus it is very less, 0 0. So your probability will reach to 1. How? Let me show you. E to the power u car matlab e to the power 100, right, divided by e to the power u car means e to the power 100 plus utility for bus is 0, e to the power 0 is 1 plus e to the power 0 is again utility for train is 1. So if you see this numerator and denominator in terms of magnitude, they are more or less same, right? So this will reach to 0.9999, right? That means you have the highest probability that you are going to take car, because the utility for car was highest. Okay, now based on this understanding, what I can do, I can calculate the utility of our car different mode for an individual. For example, I will take data from you. Okay, what is your travel time, which mode you are choosing. Let's say he has reported that he is choosing bus. Okay. Now what I will do is I will identify what is the utility for him by train, what is the utility for him by car. Okay. And then I will develop the probability that he may end up choosing particular bus, which will be, let's say, nearly 60% or 70%, let us assume, right? And if I'm doing this for the whole study area or for whole set of people, then I can predict out of 100 trips, because finally what is happening, I have this Tij, how many trips are going from I to j. This information is there. Somehow I have to distribute them in a way that I should get Tij m. How many trips will be going by car, how many trips will be going by bus, how many trips will be going by train, right? So if I calculate this probability, let's say for travel between I to j, I know that the utility for car I have calculated, bus I have calculated, train I have calculated. Now what I will be doing, I will be finding out probability. Probability by car is 10%, probability by bus is 30%, and probability by train is 60%, right? So can I convert this probability now to number of trips? Yes, because I know 100 trips exchange has to happen between I and j. Utility or the probability between I and j for choosing a specific mode is known to me, right? So this will be 10 trips by car you will be observing, 30 trips by bus you will be observing, 60 trips by trains you will be observing. So finally we have converted Tij to Tijm, that is trip exchange between I and j by a specific mode m. Okay, so mode choice is also clear, right? I'll just briefly give you an idea. There are the ways in which you can develop your model or utility. Somehow you have to calibrate meaning find the values of betas, right? So there are different ways, as we have discussed. You can end up doing a stated preference experiment, or you may end up doing a reveal preference experiment. Stated preference experiment is done when you want to analyze hypothetical scenario, right? In future, if metro is coming, are you willing to choose metro or not? Reveal preference surveys are done basically to understand what is the current situation. So reveal preference is related to existing situation, stated preference is related to hypothetical situation. This tends to develop attributes in the sense when you collect data. So what you are asking them, which mode you have taken, right? And you also inform that okay, do you know that bus was also available to you? That guy will report, yeah, I know bus is also available, but the travel time by a bus is 20 minutes extra than what I am facing currently by autos, right? So your information, or you collect actual attribute levels, right? I'm collecting actual attributes level. What is the travel time he faced today, and what was the travel time by bus, that if he would have chosen bus, then what was that travel time? I'm collecting information on actual data. Whereas in stated preference, what we do, since we are dealing with hypothetical situations, the attributes are also having certain hypothetical assumption. So basic assumption, for example, if I tell you that bullet train is coming into picture in future, right? So you currently have Vande Bharat for intercity travel. Let's say traveling from Vijayawada. Is there a train from Vijayawada? Vijayawada to Hyderabad, right? I think how much time it is taking? 3 hours, 3.5 hours, 4.5 hours, right? And traditional train might be taking 6.5 hours, 7 hours, right? And I'm telling you in future bullet train will come into picture, right? Are you willing to shift to bullet train or not? So in that, what I'm doing, I'm giving you a hypothetical scenario, and I have to assume hypothetical values of travel time, travel cost, right? Let's say I assume that the bullet trains are going to reduce your travel compared to Vande Bharat by, let's say, 2 hours, right? So if currently it is 4.5 hours, it will be 2.5 hours by bullet trains, right? So what I've done, is it true that it is going to reduce by 2.5 hours? I don't know. I'm just assuming those values, hypothetical values, right? So how I'm collecting responses? I'm collecting responses on hypothetical values. The attributes, the travel time attributes or the information related to travel time, travel cost are again hypothetical, right? Today's Vande Bharat fare is somewhere around, let's say 2000 rupees, right? Between these two cities. So I'm assuming that it will be somewhere around 3000, 3500 for bullet train, right? And I keep on doing certain exercise. Let's say if it is 3000, are you willing to shift to bullet train? If it is 2800, are you still willing to shift to bullet train? And then you will finally decide, okay, 2500 seems reasonable because right now I'm paying 1800, and you are telling me that if bullet train is coming in picture in future and the travel time is reduced by 2 hours, I have to pay additional somewhere around 800 rupees. So I'm fine with paying 800 rupees, right? So in stated preference, this exercise what we have done is related to stated preference. So in stated preference, we are collecting responses over hypothetical scenario. Okay. Now in general, we are talking about mode choice, but utility based theory are important for most of the econometric models, or wherever you want to analyze, understand preference of users. Right now we are doing it for mode choice, right? Maybe you can develop for your firm or for your client, you can do the same thing for residential choice. How people are weighing rent over different localities. If I tend to provide access to different opportunities, there is a gym inside the building, there is a swimming pool, there is a basketball ground, so on and so forth. Are you willing to pay additional rent? That sort of analysis can also be done using understanding choices, right? Behavior, because it is again it is dealing with human behavior choice, right? Same thing if some organization is of they want to understand how people are weighing different type of phones, or the uh, quality indicators of the phones, right, in market, right? So whether the R&D for the future iPhone, not iPhone, but general mobile companies should focus more on camera quality, they should focus more on processing power, they should focus more on battery life. How they are deciding it? They're deciding it based on collecting responses from the users, right? So utility based choice theory is not just applicable to mode choice. We are using it for our understanding, but it is applicable to all the marketing and sales related stuff that people are going to do in future. Okay. So this is just an example of how you may end up doing your exercise. For example, in this case, we have given so this is again two different type of trains. So how many of you have used local trains in Mumbai? One. How many of you have used metro trains in Delhi, or any metro train for that matter? Okay, a lot of people have used, right? So in Mumbai, there is a very interesting case. There are two different type of train. Actually, the train is same, but how they are differentiating it? A fast local and a slow local, right? What the fast local is doing? It is actually skipping some of the stations. It is traveling between point A and B only, but in between it will skip some of the station. And a slow local will stop at all the local stations. Okay. So we wanted to understand how people are weighing travel time over crowding, because what was observed is that a lot of people are actually traveling more to skip crowding. Okay, so they don't want to travel in a crowded condition, and that is why they were opting for slow trains. So we wanted to, and technically speaking, if you see in general, faster trains should have higher level of crowding, right? So we wanted to understand that aspect, and we floated them with a stated preference experiment. What we told, there are two trains, train A and train B. In train A, it is less crowded. From the image you can see. In train B, it is very much crowded, right? The travel time for train A is 30 minutes. The travel time by train B is 22 minutes. Standing time, for example, since the train is not that much crowded, standing time is assumed to be 0. That means if you enter the train, you will get a seat. Whereas in this case, the standing time is somewhere around 10 to 15 minutes. You have to be, you have to stand in this crowded situation. Then only after certain points of time, you will going to get some seat. The waiting time is 3 minutes, and the waiting time for the train B is 7 minutes. Which particular mode of travel you are going to choose if you want to choose a train for a train user, right? Then they will report, some will report, I will choose A, right? For them, crowding is very important. They don't want to travel in a very crowded state. People who weigh travel time more, they may end up saying that I will choose B because I want to reach my destination quicker. I don't I don't care about the crowding. I'm used to this crowding level. This is very less crowded compared to what I have traveled, right? So there may be different preferences of the way people are traveling, right? And using this experiment or this exercise, we were able to understand that how crowding tends to change their choice when they are subjected to certain cases. Okay, the same thing can be done for different type of scenarios. For example, there is an application in the sense there is a lot of research paper on understanding how insurance policies are being sold to different users, what they weigh more, whether it is the cost per month that they have to pay, or whether it is the return that they focus upon, right? Or what are the other benefits that are being provided by the policies, insurance policies. So in general, utility based choice scenarios or the general application of utility based choice scenarios are there in n number of places, and we are using this theory for our mode choice analysis. Okay, and as I've said, in stated preference, we may end up collecting more responses from a single user, right? We will keep decreasing the price or increasing the travel time, something like that we will keep doing unless and until he is willing to shift, right? To understand that threshold, okay, if we reduce the travel time by this much amount, then only people are going to shift to metros, or if we reduce the fare by this much amount, then only people are going to shift to metro, which is a more sustainable mode of transportation. Okay, so you can have n number of scenarios, and you can collect response or keep collecting response on those n number of scenarios, model them and understand them. So this is just an example I'm giving you. When you design your survey specifically related to mode choice, okay, so there are three important aspects in your mode choice surveys. One is the descriptive analysis or description about the attributes which are important to the user. You will give them the information that, let's say in future you are thinking to shift, or for your job you are going to shift to Bangalore, and you wanted to rent a apartment or a house, right? So these are the important services that you might be looking for, and based on that we have designed a survey. Please respond to the choice scenarios, right? This sort of information you have given them. Then you collect their socio-demographic characteristics or socio-economical characteristics, meaning what is their education level, whether they have a car or not, what is their income level, what is their family number of family members that will be staying with you, right? So on and so forth. That sort of information you have collected. And last is choice set. Choice set is nothing but you will be showing them different locality, 2-3 different localities with varying rent and service level. For example, whether there will be a gym inside the building or not, the accessibility to job. This particular locality is just 15 minutes far from your job location, right? So which locality they will choose, and there will be a set of sequence of questions regarding that. Okay, and you can use that to understand how people are weighing different service attribute and rent when they are making a decision related to a residential choice locality. Okay, now again in this, when you collect data related to mode choice, you have to be little bit careful about the sample. As we have discussed in the morning, sample is nothing but the part of from where you are collecting your data, that is known as sample, and the sample should be a good representation of your population, right? So this is a basic idea behind utility theory. We have already discussed. But utility theory, what is the logic behind utility theory? That each alternative has attractiveness or utility associated to it. Meaning each mode will have certain utility. A rational person will take a mode which maximize his or her utility. Okay, this is the assumption, and this which is true also, right? When you are going to choose a specific mode, when the utility that you are deriving from that particular mode or from that particular choice is highest, right? Then only you are going to choose that particular mode. And finally, utility is expressed as the sum of observed variable and some random variable. Measured attractiveness is a function of measured attractiveness in the sense your utility is a function of observed characteristics of the mode and socio-demographic characteristics of the user. Okay, so this is what we have discussed, that utility is sum of observed utility plus some error term. Forget about error term, that is from statistics, right, to understand this equation. But the observed utility that we are going to discuss, or it is of importance to us, is nothing but beta into z ji's, and z ji's are nothing but attributes. These attributes will include transportation related attribute and socio-demographic related attributes of the user. Okay, and you have to somehow quantify, or you have to find out the values of betas. Okay, so this is a simple derivation if you guys want to understand how we got to this equation, right? So that was the derivation, that we assume certain distribution of error term, and using that error term we end up getting the probability of a chosen mode based on the utility that we have calculated. So this is a typical utility function. So here if you see, I have identified utility for car, bus, train. There is time and cost for each and every mode, time and cost, right? Coefficient are same for time for all the modes, coefficient are same for cost for all the modes, and this is income, which is a socio-demographic variable. So what we have said previously, utility or the observed part of utility is a function of system attributes and socio-demographic variable of the individual. So here socio-demographic variable is income and time and cost are the system attribute. Okay, now can you tell me why we have coefficient of time for all the modes is same, right? Minus 0.23, minus 0.023, minus 0.023. And for income, if we see, it is plus 0.03 into income for car. For bus, it is minus 0.01. And technically, here it is 0. 0 into income, right? I can write, right? For train, what is the coefficient of income? For train, what is the coefficient of income? 0. Right? I can write 0 into income. So why is it that time has same coefficient for all the three modes, whereas income has different coefficient for all the three modes? So technically speaking, what you are doing indirectly is you are doing a relative assessment, right? How you are deriving utility? Utility is nothing, ऐसा कोई fixed number तो है नहीं ना? Is utility a fixed number? Nothing. It's just there in your mind. So as such, what you are doing is you are doing a relative assessment. So what matters to you a lot? Difference in utility. It's not utility, but difference in utility matters, right? Meaning, what additional utility you are deriving when you are traveling by this mode instead of that mode, right? So I have the utility by train also, I have the utility by flight also. But what additional utility I derived when I took flight? I'm doing that sort of assessment, right? If I say that the utility of train is always less, then flight But am I always traveling by flight? No. I'm changing my choices. I'm seeing that change in utility. Kitna bada hai wo change, right? For example, if I'm deriving a lot of utility by going by flight, then only I'm opting flight, right? So the difference matters. Okay. Now, if you talk about a single individual, for example, about you, right? So how I'm going to create a difference if your income is same for all the three modes, right? Your income is same, and it is true for car also, it is true for bus also, it is true for train also. So how I can create that difference? By changing the coefficient, right? Because utility is the product of coefficient and your attribute level. So if I cannot change the attribute level, I will change the coefficient, right? Whereas in this case specifically, time, although the coefficient is same, but the time of travel by car is less compared to train and bus. So that will take care of the change in utility. Okay, is it clear? So this is the traditional utility equation that we tend to derive, and using mode choice analysis you can derive the utility equations here in the context of hyperloop. Okay. Uh-huh. Okay, so utility will be more or less be same, meaning same in the sense what may happen is like utility of a futuristic mode of transportation, that is hyperloop. You may end up getting something like, if you are modeling it with respect to this only, with the same data, using same data, you may time minus 0.021 cost. But here what will happen, the coefficient of income will be highly positive. Highly positive meaning, here you, if you see that maximum coefficient of income is 0.03 plus 0.03, here you may see it to be 3 into income. So if you belong to a high income group people, then you end up deriving maximum utility if you use hyperloop. Okay, so that is how we can infer this. Okay, and the coefficient don't that are system related attributes, they will not be changing their sign, are known as generic variables or generic alternatives attributes, sorry. And variables that may end up changing the sign based on the mode, they are known as alternative specific variable. Okay, alternative specific variable meaning corresponding to each mode or alternative, the coefficient will be different. Okay, so this is now actually how we are calibrating this beta value is something of interest, how to calibrate this beta values, right? So there is a very important technique which is known as maximum likelihood technique. Using maximum likelihood technique, we estimate the beta values. What is maximum likelihood technique? It is nothing but, let's say I'm predicting something, because this probability is nothing but prediction and you are doing something. Somehow I have to match this predictions in a way that whatever mode you have chosen, for that I tend to give maximum probability. If I'm able to get betas in a way where whatever modes you have chosen, I tend to give maximum probability for that specific mode, then I have calibrated the best optimal model in my case. And that makes sense also, right? Indirectly what you are doing, you are giving highest probability for the mode that you have chosen, right? So you are calibrating betas in a way which is again a technique, maximum likelihood technique. So you are maximizing the likelihood of what has been observed. Maximum likelihood technique meaning you are maximizing the likelihood of what has been observed based on your prediction. I'm predicting probability and I'm observing actual choices, right? So based on maximum likelihood technique, this is the functional form of maximum likelihood technique. We tend to calibrate the values of betas. Okay, and for maximizing, you guys might have used what? If a function, you want to maximize a function, what do we end up doing? Let's say y is equals to x square minus 2x. You want to find out the minimum value of this. How we are going to find out the minimum value of this? Sorry? So normally if you see what we are doing over here is we want to find the minimum point in this curve. This is a parabola, right? It is sort of a parabola, right? We want to find out this minimum value, right? So to find out the minimum value, I should know the value of x at which this is minimum, right? Because if you give me the minimum value at x ka value at which this function is minimum, I will directly put x over here and get the minimum value. So what I'm doing indirectly, I'm first taking a derivative of this. So it will be 2x minus 2. I'm putting this derivative equals to 0 and then I'm finding out the value of x. Got it? Meaning at x equals to 1, this particular function will be minimum. Now you can check also. At x is equals to 0, this is 0. Right? At x is equals to 1, this is 1 minus 2 minus 1. And at x equals to 2, again it is 0. That means at x equals to 1, this function has minimum value, and the minimum value is actually equals to minus 1. Right? So the same thing here we are doing. That we want to maximize this likelihood, we will write the likelihood as a function of the coefficient, right? We will take a partial derivative with respect to the coefficient, put it equals to 0, find the value of betas. Okay, and based on this logic we tend to quantify, or we tend to calibrate the utility equation. So is it clear to everyone? So this is just a general idea how like you guys can use NLogit for developing a utility based choice models, and I'm just giving you a basic idea how how do we collect data. For example, this is how you are going to collect data. So let's say first you will ask them which particular mode they are choosing, and you have coded in your data set in Excel sheet. If they have chosen train, it will come out to be 2. If they have chosen bus, it will come out to be 3. If they have chosen two-wheeler, then it will be 1, right? Excel data, normally surveys that you end up doing. What do you ask them? What is the travel time by two-wheeler? What is the travel time, or travel time by, oh sorry, travel cost by two-wheeler? For other modes also you will ask them, what is the travel time by car? What is the travel time by, or travel cost by car? What is the travel time by bus? What is the travel cost by bus? And same thing for train, right? This data you have collected, right? These are socio-demographic variable of this individual, meaning household income, to which category he belongs. Let's say he belongs to a income group of 50K per month. Okay, then household size and the number of members in his family or her family are 4, right? So finally the model that you are going to, or the data that you are going to use will be like this, meaning this is choice 1, 2, 3, 4. First one was car, second one was two-wheeler. So for the other sets, what you have given, you have assigned 0 values, and the chosen mode was given value 1. Right? Can you see it? For the second individual, that person chose third mode, that was train, if I'm not wrong. Right? So for two-wheeler, for car it is 0, for bus it is 0, but for train it is 1. Right? These are the travel time values. For car you know the travel time value, for two-wheeler you know the travel time values, for bus you know the travel time values, for train you know the travel time values. Travel cost values, right? This income, he always, irrespective of the mode, he always belongs to 50,000 group income, right? So 50, 50, 50, 50. Household size 4, 4, 4, 4, because this is not mode specific. Mode specific is only travel times. and travel cost. So this is how you have to arrange your data overall. Okay. So finally we got our data like this. As I've said, two-wheeler, train, bus, car. There were 4 choices for every individual. This is alternative ID 1, 2, 3, 4. That particular person chose car. So you have assigned 1. For rest other alternatives you have given 0. Okay. So this is the syntax. I will share this PPT with you guys. You can just see the syntax of how to develop a mode choice model or utility based mode choice model, particularly using nLogit. Okay. And there are different models. For example, one is multinomial choice model, meaning you don't assume any variability in the betas that you have estimated, right? Beta values are fixed. Whereas random parameter choice model is something where you assume that beta is not fixed. Beta is actually coming from a distribution, which makes sense also. For example, for you guys, how you are going to weigh travel time? For you guys, what is the most important factor when you choose a particular mode? Cost, right? Cost is the most important factor, right? But for a business person, time. So if I develop a model beta for you of time, let's say it is -1. So for a high income group people, it will be, this is for students, this is high income group people. It will be definitely greater than -1, right? Greater than in the sense -2, -3, whatever it is, right? That means that although we are assuming this beta values are fixed for individuals, but based on different class of people, this beta values can change. And that is what mixed logit model can handle. It will tell you that actually this beta is coming from the set of betas, right? And you just tell me, okay, you want to do a inference for a high income group people, then I will give you a higher value of beta. And you tell me you are doing a calculation for students, for them time is not that important, I will give you a different coefficient of beta. Okay, this is how you have to infer, and this is a relatively more robust model. And this particular thing is known as taste heterogeneity. Okay, taste heterogeneity meaning I may weigh, or a particular variable will be perceived differently for different class of users. Okay. Okay, so we will stop here. Then only the last part will be remaining. So we have solved, or we developed an understanding about trip generation, trip distribution, mode choice, right? Now last aspect of 4-stage travel demand modeling is left, which is traffic assignment. Okay, so we will discuss that thing later. Okay.
హలో హలో వస్తుందా? Good evening, everyone. So this is Sesidhar. I'll be taking the software part of Visum. Till now, you guys have seen various aspects of travel demand modeling, types of travel demand models, and trip generation, distribution, and mode choice modeling. So now we'll see the part after we come from the field visit, after we collect the data, how are we going to actually model it on the software. How many of you ever had used PTV Visum or Visum till now? So few people are working on it. And who are doing the demand modeling part, like trip generation, distribution? Okay. So today I'll just show you the network generation part until the network check. Tomorrow we'll be seeing the demand modeling part. Now, if you open the software PTV Visum, as soon as you open the software, this is what you see. you will not see the network, you will see an empty map, world map, and then you have something like this. So you just need to, it has an integrated maps within the software. You have to just zoom into your desired study area and you can start drawing the network. This is for the case where you want to digitize your network in the Visum software. So here you have few things which are important. First is the network objects palette. In the left here you can see that. So in the network objects palette you have all the objects which you need to create in the network. For example, the nodes, links, turns, zones, territories, OD pairs, and if you go further down you have certain aspects related to the public transport, which is the public transport lines, line routes, fare systems, and all this. And on the top you have the taskbar, which has various options of the menu where you can set the demand models and you can set the transport systems, transport modes, assign them to the demand segments, and also you can make the procedure sequence of the demand modeling part. And the main majority part of your screen is occupied by the network editor. So is network editor is where you do most of your editing, most of your creation, and most of changing the network objects will be done here. And in the left bottom corner you have a quick view where if you select any object you will get the details related to that particular object. So this is the introduction to the basic interface and understanding okay what is what in the software. So now let us first understand how this particular software works. It has two parallel parts which are running and which are dependent on each other mostly. One is the demand model. In the demand model, it has the basically demand data, the trip generation, origin, destination, from where to where, which zone I to which zone Z the trips are going, and number of trips generated by each demand segment, and temporal and spatial distribution of trips. Everything is in the demand model. And secondary model which you have is the network model. And the network model, what we do is we create the roads, we create the junctions, we model the junctions, and also we create the zones which are nothing but our TAZs, traffic analysis zones, which we call. And then we have different transportation systems which are nothing but the private transport system and public transport system. And again within that we have different transport modes, let us say car, two-wheeler, and if you see the public, there you have in the public transport you have BRT or city bus system or metro rail, all this in the public transport. And then after you have all the data related to the demand model and the network model, then you go into the impact model where you have three types of impact. So first is the user impact model where you see the assignment and the level of service calculations, which says the usability for a particular user who is going to use the route. For example, if a person sees that V by C ratio is above 1, he will understand that there is a congestion on a particular link. And in the second is operator model. In the operator model, let us say for example, if there is any public transport operator or metro rail operator, what he need to know is what is my operation fare, what operation cost, what is the revenue I am going to earn out of it, and what is the passenger capacity or what is the passenger demand which I am going to get into my system. This is the operator model. And the third is the environmental model where we are going to we can measure the impacts on environment of a specific city level demand model which you are preparing. And at the end, finally, what you need is the results where you generate certain plots and graphs and maps where you show in your base year modeling and origin year modeling, and you justify and identify various problems based on the results of the model. So this is the theoretical backing between the software. And yeah, so when we talk about the modes and transport systems, so there are various modes and transport systems, but they have been divided into basically public and private. So here we can see that walk, bicycle, scooter, car, motorcycle are mostly a part of a public transport system, but they also contribute to a segment of private transport system in the form of a ride and share services, vehicle sharing services, and obviously normal public transport modes are there, which are totally a conventional public transport system. So for example, while we say ride and share means, let us say someone is using their two-wheeler, they are parking at the metro station and they are using the metro from there. Or let us say there is a coupling of trips between two different modes. So that kind of a modeling where private transport contributes to the public transport. And now after combining both these, then we have a finally multimodal kind of assignment. So yeah, so this is a further breakdown of the transport systems which we have. Let us say here, for example, if we see a transport system 1, which in this case is a freight vehicle, and the particular freight vehicle has its own demand matrix, so which is nothing but your freight OD. And secondly, we see the transport system 2, which is car. Then here further we have a breakdown in car, which is used for private and also which is used for business. So to have two different OD matrices. And similarly, the combination which I was talking about, the park and ride system, here we have car, bus and transport. Here we have a particular new demand segment which is park and ride, which I will show you. And here they have a particular demand matrix for park and ride. And similarly, we have a separate demand matrix for public transport based on the demand groups. So first, as soon as you open the software, what you see is something like this. So it's just a normal empty map. Here you have certain functions of the network editor where you can create and modify things. Now you just need to zoom into the area of interest, but before that, first you need to update few basic settings in the software which are found in your network settings. So in the network settings, as soon as you open the network settings, it will ask you to give a name. You can give any name. Let us say we are doing it for Vijayawada base here. And system of units, generally we use metric unit, so you select metric here, and the direction of traffic is right hand traffic, of course, so you select the right hand traffic. So if you go into the second tab in the basic network settings, here it is asking you for calendar and analysis period. So basically calendar and analysis period is when you count, when you have data like traffic volume count, you have it for a continuously 365 days. Okay, or and there is a change in the demand with respect to seasons. Okay, let us say the traffic volume is for example higher on weekdays or working days compared to weekends. Okay, and similarly there is also a seasonal variation, and also there is a seasonal variation in terms of mode share. So to account these kinds of things and to account these kind of variations in the demand and traffic volume, what we'll need is a calendar algorithm or a calendar base to your model. So here you set the calendar to annual calendar and start and end periods based on whatever data you have collected. And if you go into the third, now here you have a coordinate system. So let us say you guys must have used the GIS software. So many a times what happens is you generate your network in the GIS and your shapefiles in the GIS and you try to import them in the Visum. So to match the coordinate system, if the coordinate system is different, then your shapefiles will not sit in the exact place where they are supposed to. So here you select the appropriate coordinate system. And if you are using Visum software to generate, then it's not required. Otherwise, even if you want to export the files from Visum and use it in any other GIS software or any other software, then you will have to assign a coordinate system. So these are the basic things, and attributes, the basic attributes which you have, the speed, travel time and all the decimal points, precision of the attributes you can decide here. And similarly, yeah, basic network objects, public transport, related to public transport, link orientations and configuration of turn types, the basic things you can define here. So these are the first things which you need to do before starting any kind of editing in the software. So after this, what you need to do is set up the transport systems, modes and demand segments. Now, if you go to the tab of demand, here you find the transport systems, modes and demand segments. So by default, what you will find is bus, bicycle, car and walk. But generally, we will not have much detailed bicycle data. So you can just delete the bicycle. Public transport, you will have the data. Car you have, and walk you need to have the walk, because walk is generally considered and walk is treated as the access and egress mode of public transport if there is no other alternative. है ना? What are the various aspects of a public transport trips? What is the various aspect of a public transport journey? Three different aspects of public transport journey. क्या क्या होता है public transport trip में? What is last mile and first mile? Have you ever heard of last mile and first mile trips? Access trip, mainland trip, main haul trip and egress trip. Dispersal trip. Na? These are the three parts. So in this public transport, what we do is we model a public transport network. Let us say हमारे पास metro line. If we have a metro line, we digitize the metro line, and even if we have a city bus, we'll digitize the city bus. But the access from first mile and to the egress to the last mile is taken from walk, if we are not modeling any auxiliary relation between, let us say, two-wheeler sharing and car sharing systems. So now here what is missing, which we use majorly? Now bike is there, car is there, walk is there. What is missing mode? IPT, yes, and two-wheeler. So to create any mode, you go here, you just give a code, type of this mode, it's obviously private. What is the PCU of two-wheeler? 0.25, or if you are using Indo HCM based calculations based on your road length and all these dimensions, whatever value you get, you put that. What can be the maximum velocity of two-wheeler? Maximum velocity of two-wheeler can be around 80 km per hour. So these are the codes. It is asking for demand mode and demand segment. Just click OK. So now new mode has been generated. Two-wheeler under a private transport. Now after creating the transport, just I have shown you two-wheeler. If you have any data related to IPT or any other transport systems, you can create them accordingly. So done. Now you have defined the different modes which you are going to work on, and after defining the different modes, then what you need is a network. In network, as sir was discussing in the morning session, there are different types of roads based on their functions. There are arterial roads, subarterial roads, collector streets, residential streets and local streets. Now while creating a model, you need to basically formulate till what extent your model will be there. Is your model going to look into local level traffic, or are you only going to look into a city level which is just restricted to collector level streets? So based on your policy of the model, you decide what kind of link types you need to generate. So if you right click on links, go to the list, here you have link types. Right click on links, go to the list, here you have link types. So there is one general link type which is there. Let us name it arterial. And what are the types of transports, or what are the modes allowed on this link? You select everything. Arterial, generally you don't have a single lane, so at least you have 2 lanes on an arterial road, or sometimes you have 3 lanes per direction. So I'm just giving in a generalized way, but based on your data you can input it and you can change it to the each and every specific link. Now capacity, you can keep it maximum, but what is the general per lane capacity? What is the general per lane capacity in terms of PCU? 5700. कैसे भाई? 3500 PCU per lane, है ना, per lane per hour. ठीक है? So you can input your capacity based on number of lanes, and VO is the velocity of private transport. What is the speed limit of a specific link or specific road which you are working on? You can keep that. Generally arterial you can go till 100 km per hour, 80 to 100 km per hour. And V minimum you need to keep it 0, because if you don't keep it 0, what happens is, in a congested situation, when you're dealing with a volume delay function, the vehicles will not come to a complete halt, which will not reflect the exact situation of on ground. And again similarly, system wise maximum volume. Okay, transport system wise or mode wise maximum volume. So two wheeler we have already designed 80, car they have predefined it as 200 km per hour, but for Indian condition we can't go 200 km. Maybe we can take it 120 as maximum. So public transport, yeah, 50. And pedestrian walking speed generally 4 km per hour. Similarly, what you need to do is you need to create one more, which is subarterial. In subarterial, let us say the speed, maximum speed is 80. Now in some cities, what you have is vehicle wise speed limits are defined even for a subarterial road or arterial road. If there is any such case specific scenario, while creating the link, you can update these values. So two wheeler I am saying 60. And again after the subarterial we have collector. So the rank of the road will define the hierarchy. Let us say you are ranking arterial as first, then the first priority will be arterial to assign the trips from origin to destination. So this is the basic part, defining link types. Once you are done with defining link types, then you need to go to the network editor. So here you have nodes and links. In this particular Visum, what happens is first we need to plot nodes and then we need to join them using links to generate a network. Okay, in GIS and in Visum, it is opposite. You create links and then you make the nodes. Wherever the link intersect, that will become a node. Okay, here first you generate the nodes. And then you create links. So to generate nodes, it's simple. Just click on nodes and here you will find a create symbol, insert mode with a plus sign. Click on this insert mode and then just add nodes wherever you feel you need to generate network. So now the reason I am saying what level you need to go in your network is, if you observe this particular case, if you observe this particular network, here you have an unnecessary loop in the network which may not really make a sense when you are looking it in a larger scale. Okay, because you are anyway making TAZs to aggregate your traffic, and the traffic within a TAZ, or the trips which are generated and attracted within the TAZ, internal to internal trips of a TAZ, are anyway not accounted. So going in very much detail level may not be necessary if your TAZs are at least 2 to 3 kilometers in size. So once you create all the nodes, then just click on links, move to any node, just a simple click, and just digitize it by adding the vertices wherever you feel there is a curve or there is a deviation. So once it comes to the end node, just click, then a create link dialog will open stating that from node 1 to node 2, what is the type of road which I need to assign. So this is a basically main road, Elu road, which comes from whichever bus stand to your college side. This is the arterial road, so I am selecting arterial road. And if you select close opposite direction, if there is a one-way kind of a situation in any road, then you take the close opposite direction. Or otherwise, if the opposite direction is also same, then you select like outward direction. Let us say if some cases opposite side is a smaller road, then you select this accordingly. Now one particular link has been created. So if you go to the list of links, here you can see the link. Now two are created because it is a bidirectional. And the length of link is automatically calculated, number of lanes is also there. And now similarly, you just join the points. So it's best that you do all the arterial at once so that you don't need to change it always. And then once you're done with it, you can come to secondary levels of roads. So now I have joined this, but I realize that there should be a node here. So let us say if I need to join here, if I go and create it like this is wrong. Because here, from here the traffic can turn left. If you observe it closely, from here the traffic can turn left. If I create a link like this node has been overwritten. We have not considered this node. So now if the traffic has to turn left, it will go till here and then make a U-turn and come left. Now let us say I have generated the link like this, and after generating the link, if I place a node here, still it is not going to work because it is not going to consider that path. The total network is missing that particular path. So just for example, I have told you like what kind of errors might come when you keep on digitizing an exhaustive network. Now here what I have done, I have given it as a subarterial, but as per my basic definition, in the subarterial I have given two lane. But here I can see that this is only a single lane per direction. In this case, you just double click on it, and the number of lanes, you can just make it 1. Now this 1 is showing in yellow because it is saying that the opposite direction has 2 lanes and the 2 direction has 1 lane. Now just click on transfer changes to opposite direction. The yellow is gone, means the opposite direction also have become single lane. So now once you are done with your network, now you have your nodes and also you have your links. Now what is missing is, if you travel in Vijayawada or if you just try to relate this particular intersection, there are few signals. And if you see the node list, if you just double click on any node, you have 4-5 things here. One is the node direction where the traffic is flowing. Second is the links which they are connected to. And the third is the turns from each and every direction and the geometry of the road. So now while we are doing it roughly, we are not giving attention to the minor values or minor curves in the geometry of the road, which may be entirely different on ground. So if you have any CAD drawings or detailed drawings of this particular road, then you can input it, or otherwise you can just create intermediate point and just modify this geometry to make it look like on ground. Okay, now if you just click on node, go to the right click on node, and there is an option called signalization. If you have any node with signal, you need to create a signal controller. So in the signal controller, basically you need the cycle time, amber time, green time, red time, yellow time, and the signal stages of that particular node junction. So any signal has signal groups. Signal groups is the combination of signals which turn green or red simultaneously at the same time. you need to create the signal groups based on the data which you have. And then you have the signal stages. So in this stage you can select so after you create the signal stages, you can select which direction will be turning green in which stage based on the data you have, and which will be red, and then the sequence of the stages. So after creating the sequence of the stages, when you go to the signal program, the actual signal program which you need to work, then you'll see something, a diagram like this. So where you can select the signal sequence. And cycle time you have to modify based on the data. Let us say here it is 120, but I am making it 160. Offset time, let us say 5 seconds. So like that you can generate the signal program based on your data. And use it in the notes. This is basically to understand, let us say in further you are going to give any proposal or you want to modify signals and see how it is going to impact the congestion or impact the traffic volume V by C ratio on that particular road, then you have to use this kind of a data. So wherever you have those kind of junctions or intersections where you need to analyze the signal, there you need to give the signal data, and you have to sure assign the node which you are using this signal for. Let us say here we are using node number 1. Node number 1, you will put it in the allocated nodes. And then if you need to optimize this signal, means you are saying the software to run the simulation multiple times and give me the optimized signal values, then you set those parameters here. What should be the minimum cycle time, maximum cycle time, and what should be the optimization method. Means is it should it optimize based on the cycle time and green time, or should it optimize only based on the green time for the each stage. Okay, signal coordination, basically you have 4 different junctions, let us say 4 different junctions in a network, and then you need to change the signals based on the feedback from the previous signal. Let us say previous signal have turned green and it said that the traffic is clear, then the second signal also need to turn green. So these kind of situations can be generated or simulated using the signal coordination systems. And similarly, you have daily signal program. Let us say Monday to Friday, this you have one kind of a traffic pattern which suits a particular signal program, and on weekends you have a different kind of a signal program. In weekends, you can see mostly the signals turn into the orange blinkers, or then the cycle time varies. So all these things you can just do by creating different signal schedules for each and every node. So each node has a different signal, and each signal has a different signal timing for each day, and they have a different coordinate system. So yeah, anyways, if you wish to do, and if you have that level of data, then you can utilize it. And once your network is ready, I'm just showing a sample, then what you need is zones. So now you have modeled your nodes and links, and now you are modeling zones. So zones, why we need zones is basically, as we were discussing, for an aggregate based travel demand modeling, we are assuming a homogeneous kind of land use and a homogeneous trip characters in a specific zone, because we cannot individually model each and every trip. So we are assuming a group based aggregation, spatial area based aggregation, and land use based aggregation, so that we can achieve a homogeneity and model it accordingly. Now when you create the zones, once you are done with the network, you need to select the zones. Again, go on the insert mode, and just first you need to insert a zone centroid. What is a zone centroid? What is zone centroid? Household group. So zone centroid is a point in a zone from where basically the trips are assumed to origin and end. Now while you are aggregating it spatially, you cannot consider each and every single point in the zone as an origin or destination. So you are saying all the trips of this zone are originating from a zone centroid, which is at a particular location. Now your zone centroid, while you are placing a zone centroid, it should ideally be located in the center. Otherwise, the trips, while you are assigning origin, destination, or trip distribution, they might assume, or they might confuse between the zone centroid of adjoining zone and the zone centroid of your particular zone which you are working on. So first you need to place the zone centroid here. Now the zone centroid is placed. You start with the any edge of the road or any node. Click it here and then move in a anti-clockwise direction. You need to move in anti-clockwise direction, because if you move in a clockwise direction, what happens? It will go outside. So just move in anti-clockwise direction. And digitize along your network so that your zone is formed. Similarly, one more zone centroid. Now your zones have data related to socio-economic or socio-demographic data, such as the population and land use, because you need the population and land use in the productions and attractions. Hai. How do you calculate the productions in trip generation? What is the measure for productions in trip generation? Yes. How do you calculate trip generation? Trip generation. PCTR. What is PCTR? Per capita trip rate. Where do you get this per capita trip rate from? C ठीक है, CMP से जुगाड़ू तरीका ढूंढ के लगा दिया. But generally, how do you get when you do survey? Huh? Each TSZ, you collect the household trip diary, right? You collect the household trip diary. For every TSZ, you have certain number of samples. In that, you have the number of trips, number of persons. So population divided by trips is per capita trip rate, which is nothing but for every person, how many trips they are making. है ना? So for that data, what you need? Zone wise, you need population. If you have further classification, you need working population, non-working population, population with vehicle, car, population without car. Okay, because their trip rates might significantly vary. And similarly, you need the land use because you need to calculate the attractions. Or otherwise, you calculate the productions and attractions outside and just import it into your zones. ठीक है? So like that, you create your zones. Now, once you are done creating your zones, what is missing here? You have nodes, you have links, you have zones. How will the trips go from the zones to links? For example, here you see the zone centroid is here, number 2, and the road is here, link is here. How will the trips, we are assuming that the trips will be generated and attracted from zone centroid. Now, how will the trips move from the zone centroid to the link? For that, we have connectors, PUT and PRT connectors in the software. So those connectors are used to transfer the trips from zone centroid to links. So here you have an option of connectors, and when you right click on the option of connectors, you have option to create connectors. So here you have two different things, generate PRT and PUT connectors. So right now we have only just created a private network. We have not inputted any public transport lines or routes. So we'll just create PRT connectors. Now it has a maximum length option. How do we decide this maximum length of a PRT connector? Let us say I have created a zone of 2 kilometers. This zone is of 2 kilometers and I am giving a maximum length of 1 kilometer connector. In that case, what happens? No connector will be generated. इसमें भी generate हुआ. Let us say 0.2. Okay, so you need to give the maximum length of a connector, direct distance connector, accordingly, so that it will address all the directions. Now if I am giving only direct distance of 0.1, I only got the connector on left direction. Means let us say the trip who have to go this side, they will be assigned left side and they will be making a roundabout to reach this particular destination, where the ideal path is the trips being assigned here and from here going to here. Okay, so that is the reason you need to make an appropriate length of the connector, maximum length of the connector, and what should be the number of connectors per zone based on your zone size and the distance. So now once you are done till here, you need to conduct a network check So network check will tell you if there are any errors or inconsistencies in your network. Before that, after you are creating your zones, so here you can see while creating the zone, there is some overlap in my zones. Because how much ever we use the accuracy, sometimes we have some overlap. For solving that overlap, we have an option called fuzzy surface alignment. If you right click on your zones after creating the zones, which are TSZs, you have an option called fuzzy surface alignment. Here what happens is these kind of irregularities of zones will be addressed and they will be made into a homogeneous edge. So now you can see that the issue is to an extent solved. There is no overlapping on the zones after running the fuzzy surface alignment. Now after this, once you are done with this, you need to do a network check. So in the network check, basically you will be checking if are there any unconnected links, are there any unconnected nodes, are there any zones without connectors, are there any links with capacity assigned as 0, multiple overlapping turns, zones without any network, link orientations, and after you generate the public transport network, then you go into the public transport parameters. But right now we are only on private transport network, so we'll just use this. So you need to get all ticks. If you are getting any warnings, means there is some error. Here I have left one node. Here I have left one zone without connecting these links, and also there is an isolated link which is not leading anywhere. It is just abruptly ending. So I am getting few errors or warnings. Now these warnings may cause trouble for you in the future or may not cause. It depends on what your application is. So I think till now you guys are clear on how to generate a network and generate the connectors, private connectors. So till here you generate your network, or if you have your network you bring it tomorrow. Tomorrow we'll see how to add the public transport based on the public transport fares, public transport systems, the timetabling, scheduling, and then the public transport demand allocation. Then we'll go to the demand segments and see the trip generation, distribution, mode choice modeling, and trip assignment. Finally, how to evaluate the results of the trip assignment based on the links assigned to the volume, or based on the volume assigned to each and every link. Okay, and if you have any specific doubts in your network which you are working on, we'll discuss tomorrow at the end of the session. We'll have a 1 hour doubt clearing session. There you can bring your network, and if you have any specific errors or doubts, we can solve it in that. Okay, clear till here? Any doubts? Okay, we'll see you tomorrow. Try to digitize the network. If you get any errors or doubts, we'll clear tomorrow morning.
I think masters, you build this network tonight. You can rewatch the video by using that link, whatever the link we have shared in the groups. So rewatch the link and build your network. B plan second is you try to you install the software. You try to build a network. Follow this procedure. I'll be sharing one manual to you in that group. So you build with your network and you come tomorrow. So we'll continue the next session. So tomorrow morning we'll be starting with Dr. Gajanand Sir lecture series. Then we'll be going ahead with the software. Okay. Tomorrow morning sharp 8:30 p.m. We'll have a group photo now at the outside this place at the pillars. So please be go there. Yeah, here. We'll have a group picture. Thank you, sir. Thank you for today's session.